I was muted. Okay. So today I'm bringing two people together to talk about the electric universe theory. Dr. Aaron Adair, he's been on this channel a few times before, and Sean Andrews. He actually appeared 3 years ago, even before I created this version of the channel. Anyway, um, back in the Facebook live show that we did like 3 years ago, and I re-uploaded it on this channel back in early 2020. And today we're going to be talking about um, just as I was saying earlier, of electric universe theory, the apparent pros or cons of it. Um, so, Sean, I think I'll just pass the mic to you because you can kind of tell people about the electric universe theory briefly and what you think about it, and Dr.
Okay.
Adair can just jump in on that whenever he's
Um,
ready.
well, I'd like to say thanks again, guys, um, Jacob and Dr. Adair. Uh, I'd have to give a little background about myself, in that I was raised a fundamental Christian. I got twisted up at one point in time in my life, more than 20 years ago, into the Black Hebrew Israelite doctrine of religion, and got to a point in my very early 30s, I'm in my 50s now, that I questioned everything that I had been taught religiously and historically, through school, Western education system, university level, and I emptied my cup essentially, which isn't easy to do, and started over again. I looked at mainstream science models for possible explanations to even weirded out things like Zachariah Sitchin's work, or people believing in sentient beings, angels, the whole ball of wax. Um, did a lot of reading, researching, and maybe about 12 years ago or so, I considered the works of Dr. Emanuel Velikovsky, which I had never considered before. I had heard about them. I was introduced to them in middle school, essentially, from a geography teacher, and never considered it, never really had an interest in even looking into it. Um, I was always perplexed with ancient religious texts and ancient cultures as to why they were thinking the way they were thinking, essentially, and could never kind of figure it out. I read Dr. Velikovsky's book, Worlds in Collision, and was like, whoa. Not only did I read the book, I checked his sources. I tried to see how he's putting this thing together. Well, for a guy like Dr. Adair, who's a mainstream scientist, the preface of the book starts out to say that if you think Darwin and Newton are sacrosanct, this might not be for you. And I'm like, okay, wow. Okay, you need to explain. So, in a nutshell, Dr. Velikovsky proposed that our ancient solar system wasn't configured the way it is today, to make it real simple. And the only way that the ancient people would have written what they wrote about creation and catastrophe the way they did, we can't live in a solar system where gravity is the only thing that's the primordial force, if you will. That electromagnetism has to play a part in it or a role in it, um, or then what the ancient people are describing is just hogwash, essentially. I hate to say it that way. Well, because of him, coming up with this book, and the story is the story. Macmillan is going to publish it. I had Macmillan school books when I was growing up. Before this book with this radical viewpoint was published about catastrophe and maybe the role of electromagnetism in the ancient past, there were like 4,000 scientific papers written against him before the book was published. It was a bestseller. It raised um, a lot of issues, but at the same time, it was highly controversial. Dr. Velikovsky's book publishing rights were sold to another publishing company because of the pressure of the scientific community. To Macmillan, the publishing rights went to a company called Doubleday. The book became it was still a bestseller, and I say let the games begin because it was very, very, very controversial. Um, we hadn't even had any space probes at that point or satellites in space to measure anything, if you will. So Dr. Velikovsky, to put it in a nutshell, he made some predictions. Okay, and based on ancient literature alone, which is pretty, you know, that's a wild thing to me. And his three predictions were Jupiter would emit radio waves or radio signals. Um, Venus, the planet Venus, would be the hottest planet in our solar system because it behaved like a comet in the ancient past and was terrifying. And that the moon would be full of magnetically charged, I'll say, rocks, if you will. Well, he was right on all three things. The mainstream prediction of Venus was to be a twin of the Earth. Well, that wasn't the case. The theory of the runaway greenhouse gas effect, and that if we want to come up with answers to questions, we're going to have to take a deep look within ourselves internally. We all have intellect, and we're going to have to do a better job in terms of how we gather information, disseminate information, what to compare it against. You have to widen your scope. You have to change your methodologies, maybe. I'm not one here to say Electric Universe is right on everything, but I'm also one that's going to say that they're not wrong on everything either. And that Velikovsky was right on some things and he was wrong on some things. The Thunderbolts project and that group is their modern day neo-catastrophists with Dave Talbot and Walt Thornhill being the spearhead leaders, if you call them, of the group. They spearheaded the thing, if you will, with a bunch of other guys. Ancient mythology, comparative mythology, ancient history, the psychology of human beings. Are we right on everything in terms of cosmology and geology? Is there a different way of looking at it? Well, they would say yes. They would say that, the uniformitarianism way of looking at things is one way to look at it, but then a catastrophist way of looking at it is another way of looking at it. So we're looking at the same things and we have two different interpretations of the same thing. I know why a guy like Dr. Adair would probably oppose the electric universe. What me, then as a layman, because I'm not a scientist, what I would say to kind of get this conversation going is what I need from mainstream cosmology, then I know there's an explanation of how things work. The first question would be, can we duplicate that in laboratories on the Earth? Can we show it in a lab? We've already had the observation. Can we duplicate it in a laboratory? Maybe tweak the model a little bit here and there when you're doing your experimental work, and use the experimental work then to make dead on, 100% accurate all the time predictions with no errors. And I'm talking like no errors at all. It's either got to be this way or no way. If it's slightly off, then the whole thing is off. So I rely on those guys, I would say, for their predictive nature, with the model that they use, rather than looking at the mainstream cosmological way of looking at things, because then I would see that there are errors in the predictions and we're not on point with our predictions. We're just not. I've seen that for a long time. I guess I could pass the mic because I would have more questions than anything. Would at least, because I'm not an electrical engineer. Boy, I wish my friend Neil was here. He's an electrical engineer and he's way more well versed with electrical science and the terminology than I am. That would be something that I wish could happen, because I'm sure, again, you guys have different disciplines. But that's why I swayed to the electric universe, because of the predictive nature. I also see that it's not going to overthrow mainstream science, nor will mainstream science take parts of it maybe and intertwine them together, because they're operating from two different worldviews. And a person would have to completely change their paradigm to be able to maybe even accept some of the things that they say. So I understand why there may be hostility with some people that are mainstream scientists. Why sometimes the electric universe people, when they look at it, they become hostile toward other people, which they shouldn't. But I can see why that happens. But it would be an interesting conversation. We could probably talk about this stuff, which would be cosmology and geology, okay, ancient comparative mythology, history, and chronology. They're like that's like a 5-lane synthesis. there's different lanes within the synthesis. So it's just not one thing. It's more than that. So um, that's kind of briefly, what the electric universe is. Um, and I can pass the mic on to you, Doctor Adair, and we can kind of just bust it up and chop it up because I do respect your scholastic um, work. Then, obviously, as a physicist, I can't argue with you. How am I going to argue with you? I'm just a person that's looking for answers because I have questions, and I think the electric universe is better suited to provide me answers, though it's really controversial stuff. It is. Is it pseudoscience? I don't think it is. Are the guys that are the principal members of the electric universe nut jobs? No, I don't think they are. They just have a different worldview. And unfortunately, a lot of us do. Us human beings, we're not all together. We're not on the same page. I wish we were, but we're not. So I've been considered to be a upstanding, intelligent, uh, older person or older man by the members of the group, and they respect, my scholastic opinions about certain subject matter, and that I'm intellectually responsible in my endeavors of trying to problem solve, if you will, in a nutshell. Um, so with that, I'll pass the mic because I'll talk too long. I'll talk for an hour.
Well, now you have to be careful because it's not like I'd like to stop talking either.
Right.
Yeah, so I, of course, come from a primarily, you could say standard mainstream. I don't know what term might be the most appropriate or least loaded way of saying, come from a normal science background.
Okay.
Had been, interested in, loving science since I was a little kid, knew that's what I wanted to do, got my PhD in physics eventually, and got to play with some fun experiments along the way. Also, was a teacher at high school and college level for several years, so also got to teach it back as well. And also means that a lot of the things that we talk about, we can literally say, hey, we can literally do the experiment and see, energy and momentum are conserved in collisions, or we can see how an electric or magnetic field will bend the path of electrons so we can figure out the mass electron ratio, all sorts of other experiments to say, and here's how we know all these little foundational points in modern physics. I had first, I think, heard about Velikovsky and his ideas actually through Carl Sagan in one of the reruns of Cosmos from 1980. I had read some of the history about his ideas. In particular, there was a history of the Velikovsky affair, that's usually called. You had mentioned the issue with his book publications.
Yeah.
So I know a bit of that history. I've seen some of the arguments. I've read some of Worlds in Collision and things like that. And the reason I would not find it convincing isn't because of paradigm. It was because has what I would say are things that are fundamentally flawed in method, are in many ways factually incorrect, and also just in a methodological point of view, the way that I would approach wanting to understand the past is which methodology is more reliable, tests that we can do here in the lab, or interpretations of myths from ancient cultures in ancient languages that require interpretation. I think the tests that we can do that we can repeat are far more reliable and what we should be using to look to the past of what was going on. And also the fact of the matter is, when people were writing these ancient stories, they were not writing it for us. They were not writing in the way we would expect. We have to understand how and why they tell the stories that they do, rather than forcing and imposing some other view onto it, especially if it happens to conform to other desires. Many people have pointed out that Velikovsky wanted to basically prove things with the Bible. So parts of what his book describes is trying to explain things like the sun standing still for Joshua and the miracles of the Exodus and things like that, trying to explain that with the motions of the planets coming in. Boy, oh boy, does that sound like, motivated thinking to get to a conclusion. That's what, most people would jump to, especially if what you need basically says, not only is mainstream science wrong, but we have to say that we are not really understanding some extremely fundamental things about electricity, magnetism, and gravity. Now, I think you've mentioned before, you mentioned in our pre-talk that
Mhm.
you think gravity exists, and I bring that up because, from what I can tell, within electric universe points of view, there is some spectrum of gravity is real versus everything can be explained by electromagnetism. And I'm glad that that was something you clarified on
Yeah.
earlier. But the thing is that we can actually explain so much with gravity, and where electricity and magnetism come in. We see
Mhm.
exactly the domains it comes in and make extremely exacting predictions on those points.
Okay.
So I don't need electromagnetism to explain the cycles of the moon around the Earth, and I can predict it completely through gravity. I can explain the motions of the planets without any recourse to electromagnetism. And there's also the problem that we can actually go and see how much of an effect it should be, because we can measure how large charged are objects like Jupiter or the moon and the Earth. And the problem is their net charge is zero. So how much electric
Okay.
force should there be between the Earth and the moon? There should be zero.
Okay.
So how much should electricity and magnetism come into play in explaining the orbit of the Earth around the moon? Zero. That's just what basic physics would have us expect.
Mhm.
So having it come in with a theory of, in particular, with Velikovsky saying that Jupiter spat out a comet that came and did all sorts of amazing things in the inner solar system, eventually settled into an almost perfectly circular orbit around the Earth to become the planet Venus in the historical time, and just a few thousand years ago. None of that is the least bit consistent with electricity, magnetism, or gravity. And Velikovsky, he was a psychologist or psychoanalyst in his background, not a physicist. So he never exactly provided, his equations to explain a new Lagrangian for the electromagnetic force, to explain these unusual things. And many of the other predictions that we can go through, we can talk about, and then I can say, here's how the mainstream view can explain it. Here's the evidence that we can show to support that. And while conversely, that sort of same evidence doesn't exist in that sort of context. And conversely, when we try to go back to the old myths, we might need to say, hey, maybe we are imposing things. So, for example, when I was on this channel before and I was talking about my book, The Star of Bethlehem, I was talking about, here are all these attempts by scientists to try to force a clearly miraculous star into our understanding of physics. And that doesn't work. And you can see it doesn't work if you go back to the original language and see how every single person interpreted it. So this is moderns forcing the ancient authors to say something they're not saying. And if we let the authors speak for themselves, we'll come to different conclusions. Then we need to rewrite fundamental physics.
Yeah, I'm agreeing with you on a lot, but some things I may not agree. I won't use the word disagree. So Jacob's showing some really compelling photos too, by the way. So I don't disagree that we can use gravity to predict to a degree. You mentioned, did you mention resistance? Is that what you said in terms of Jupiter?
I said that it doesn't have a net electric charge.
Okay. Now we got that. That's where I'm going to stop, because then from a basic level, and this is where they're saying the problem arises, because you're a physicist and then you have cosmologists and astronomers and astrophysicists and electrical engineers that aren't like this. They're like this, and they're not working together to problem solve. This person's may have an idea here and it doesn't jive with this person's idea over here or prediction over here. So that was Hannes Alfvén, that because they're going to cite in their books more the history of the electrical theorists and plasma physicists and electrical engineers, because we never were taught that. I wasn't learning about Christian Birkeland and Hannes Alfvén when I was coming through school system. So what they're going to say is, to have a magnetic field in a simple fundamental way, you got to have a moving charge. The field don't exist without a moving charge. It just can't. It can't exist by itself or magically. So Dr. Alfvén came up with some fluid dynamic equations to describe and deal with space plasmas, back in the 30s, I think it was. So he he made a model. Okay. So when he tested it in the lab, he's like, okay, my model doesn't work because magnetic fields never become frozen into the plasma itself. You have to have a moving charge. You have to. So there has to be a net charge, though it may not be substantial, so to speak, there's still a net charge. There has to be. So like something easy that me and my son would do is take a copper wire, wrap it around a nail, and get a battery and put a compass beside it. As soon as we create a moving charge, the compass needle moves. You have a magnetic field. As soon as you take the wires off the battery, the field disappears. It's not there. So one has to exist with the other. So what he said was in his like 1970s um, Nobel Peace Prize acceptance speech was his fluid dynamic equations from the 30s were wrong, and he would wish that astrophysicists wouldn't use them at all because he was wrong himself. When he tested it, he saw that he was wrong. So these guys are going to say fundamentally you can't have a structured magnetic field without some type of moving charge somewhere. It has to be there. So even recently, I just read a paper a month or so ago about Saturn's, I think it was the North Pole, that the magnetic field is being pulled with by electrical charge, but they don't know where the charge is coming from. Okay, well then why don't you know where the charge is coming from? There has to be some type of charge. So they're going to say that should be incorporated into the mainstream viewpoint, if you will, because then you can't take gravity itself and say it's a universal constant. Let me explain where I would have a disagreement. Galaxy rotational curves. That's the easiest example I can give. That when you use the laws of gravity, the Mercury goes around the sun faster, if you will, than the outer planets. They go around much slower. So when we go and looking through telescopes, that prediction should be that in active galaxies, the center of the active galaxy should move at one rate, and that the rotational curves would move much, much slower because of gravity. Well, that's not what the case was. The galaxy rotational curves are exactly the same. The galaxies are moving at the same pace. So dark matter is created, mathematical equation, I don't understand it, to compensate for the misprediction. So Dr. Anthony Peratt, who was once in the Thunderbolts group, who is a plasma physicist, was like, well, what the problem is you can use Maxwell's equations rather than gravitational equations in a supercomputer with no algorithms. He modified some of the equations, and he said the supercomputer yielded the results that you need to explain it. But if you use the same Newtonian equations in the supercomputer, he said it broke apart into like pieces or something crazy without an algorithm to help it. So I'm like, okay, so what is that saying? That's saying that gravity may work the way it's working, on a local level. The moon, I agree. Getting a spacecraft off the planet, I agree. But then to use it to universally predict, that doesn't seem to be the case. That's the only example that is easy enough for me to talk about with my children, things of that nature. So that's where they would disagree. They're going to say, well, hey, you didn't get this prediction right with galaxy rotational curves. Now we have something called dark matter that's going to compensate for the prediction being wrong, rather than just using Maxwell's equations. They would say that physicists and or astronomers and astrophysicists aren't taught electrical law at all. Should it work that way? I would think. You know what I'm saying? Like that's just the way I see it. I don't have a problem. I think it was Michael Shermer went to one of their conferences, and the guys don't have a problem with how we get spacecraft into space or anything like that. They just have a problem with the mispredictions when even something like when we get past the heliopause or heliosphere. We're out past Pluto, if I'm saying it right. Voyager 1 and Voyager 2. Well, the prediction should be we're in empty space. That didn't happen either. The plasma densities increased. They said that they would increase. There's no such thing as empty space. There are particles everywhere. The ancient people may call that the ether or the aether, however you want to pronounce it. You kind of understand where I'm going with this? And I'm not a scientist, so I'm just looking at what they're saying versus what I've been taught and say, well, maybe we're missing something. Maybe electromagnetism does play a role in it. But again, what they would say, well, the people, their worldview is different. And if that would be the case, then Velikovsky was right or more right at the time, and people would have to reconsider it, and we'd have to kind of backpedal a little bit, and we have to backpedal and rethink things. So even with the ancient myth, and I do take extensive notes. See this stuff.
Before we hop
Yeah,
into
get
myth,
down,
just
down.
because you jumped to a
Yeah,
lot of
sorry.
different
Go ahead.
science topics, I think we should
Go ahead.
backtrack before we add more to the pile.
Go ahead.
Okay, so you mentioned that, yes, to have a magnetic field, you need a moving charge, but you don't need to have a net charge to do that. So, for example, if you grab a bar magnet, it doesn't electrocute you. It is not actually charged, but it has a magnetic field.
I get you. So should there be some charge, a little bit of charge, not to where you go. I get that. Should there be
I'm
some
saying the
charge?
problem is that, like a regular bar magnet,
Okay.
unless you actually have charged it, it has no net charge. Now, individual atoms, will of course have protons and electrons, so there are charges, but the net charge, the total charge, is zero.
Okay.
But because you can have then moving charges internal to that and still have zero net charge, that's how you can get a magnetic field.
Okay.
So that's why I'm pointing out that right now. So when you jump to Jupiter, and yes, Jupiter has a significant magnetic field. That is true. You can have significant magnetic fields and still have no net electric charge. You just have to have charges moving around in some sort of way.
Okay. That makes sense.
Yeah. So that's some, the points on just the basic physics to clarify.
Yeah. Okay.
Now that magnetic field is significant. When we send probes there, it's something we have to watch out for, because obviously you take electronics and you stick it in a strong magnetic field and then turn it on, bad things can happen.
Right. No, I agree.
But this also means that if we're sending probes into space, and there's these gigantic electric fields that are powering the sun and all these other sorts of things that electric universe proponents will say, it seems like we should have been aware of these sources, because it should have fried our satellites the instant we threw them up into space. And yet they seem to behave exactly as we'd expect if there is the force of gravity, some solar wind, some of the particles from that, but nothing really beyond those sorts of forces. Now, you also then jump to the macro scale. You were talking the whole galaxy on a couple of different points.
Yeah.
So
that's
a couple of things.
Say. That's what they would say.
So a couple of things there. One is that first off, we actually kind of expect the structure of the galaxy to form by having things, just spinning around like that. And you have to ask, okay, so what's holding it together? If it's not gravity, if we're saying it's the electric or magnetic force, well, how does that work if the major objects in there are not net charged? Stars don't have a net charge. Planets don't have a net charge. You could put a big electric field on something with no charge, and what happens? Well, a whole lot of nothing. So how does that actually work? You have to then somehow impose and somehow turn the various stars into some sort of charge, and then have some sort of outside electric field to manipulate that to get the sort of results that would look in terms of galaxies. Where's this gigantic electric field coming from? That doesn't seem to be in evidence. Now, you also mentioned dark matter. So a little bit of background on dark matter, because it's something we should bring light to. Sorry, bad pun.
All right.
I only have bad puns. So it was a way to explain by the fact that the basic idea is that as you get further and further and further away from the center of the galaxy, that eventually at some point there's not enough mass there to continue to help hold things in place. So the things that are orbiting the center should be going slower rather than maintaining the same speed. And you mentioned just like that with the planets. Mercury is going around the sun far faster than Pluto is. But what we actually see on like the outer edges of the galaxy, the stars seem to all have about the same radial velocity. So the idea is, okay, there's another source of mass that we're not able to detect. That was called dark matter because we can't see it with our current telescopes. What that dark matter is has been a very active area of research, but it is worth noting that it wasn't there. We said we're going to use that to fix the rotation curves of the galaxies and then do nothing else. Everyone's like, okay, if this stuff exists, what other predictions can it make? What other things can it help us make sense of? If it's only there to fix a problem, then it looks like a weak theory. If it can explain multiple phenomenon, then it looks much more viable. So among the things that dark matter helps explain is the fact that there isn't enough regular matter in the universe to explain the overall structure of the universe. So we can, in a sense, weigh the universe by basically, we can look at what's what we'll call like the curvature of the universe. We're effectively using Einstein's general theory of relativity and looking at the overall shape of the universe, which is basically telling us how much net mass energy there is in the whole universe. And there isn't enough regular matter to account for what we actually see. So we need more matter than we already see out there to account for that. Dark matter already looked like it was going to be making up the vast majority of the mass of a galaxy. It helps then explain that problem. We can look at other clusters that have gone into collision with each other, and we notice other interesting things. So, among the things that we can tell with our gravitational theory is that this thing called the bullet cluster. Hopefully, Jacob will find a picture of this, the bullet cluster. It's basically like two galaxies that shot through each other, and kind of see like the aftermath of that collision as they kind of ripped each other apart through gravitational force from there. But the thing is, we can also like map out the sources of gravity because, as we know from Einstein, gravitational objects bend the path of light. We've seen this since 1919, and we've repeated that sort of experiment many, many, many times. And so we can use that to map out, and we actually see that most of the gravity of this bullet cluster isn't actually where the stars are. So it's a way that we can see basically the dark matter was ripped away from the rest of the what we call baryonic matter, the matter that we can see with normal telescopes. And again, this is something that gets explained very well by saying there's another form of matter that we just don't happen to be able to see with electricity magnetism. And I don't know of any explanation that the electric universe theorists have about this. I don't know of any papers they've published explaining the bullet cluster, but there's dozens on dark matter explaining the bullet cluster, for example. So the fact that that theory exists, it explains multiple phenomenon. It helps in problems in cosmology, in galactic formation, in observations that we can make right now with our telescopes. That makes it a far, far more viable hypothesis.
Okay. Because you mentioned that, I think, it still gets back to like a plasma physicist like Dr. Anthony Peratt, who was a part of the group, and he did synchrotron radiation experiments with the what do you call the machinery, Z-pulse power machine at Los Alamos Laboratories.
Okay.
During the time that we could test nuclear weapons, can't do it anymore. They wanted to know why there were auroras at the top of the mushroom clouds when we detonate atomic bombs. Well, Dr. Peratt's, he's an electrical engineer, and so he's gonna try to solve problems the way he does within his discipline. So Dr. Peratt's synchrotron radiation experiments, and I forget how much electricity he was using, but it was a lot. The radioactive experiments, they're detonating these charges underground, and they're like really far away, a couple miles away, looking through X-ray telescopes to see what it looks like, and they're recorded in what's called radiographs. So he does these experiments and he writes a textbook about it or whatever. But then he was invited to a conference many years later, and his synchrotron radiation experiments that were actually classified matched the images precisely that are carved into petroglyphs all across the world. Okay, the same petroglyphs that Zecharia Sitchin said are aliens and all kind of stuff, weird stuff. Dr. Peratt then was invited into the group with another gentleman by the name of Marinus van der Sloot. They did a worldwide tour looking at these petroglyphs, and they noticed that they're all oriented to the south. And Dr. Peratt's idea was that in the ancient past, then we had an increase of solar winds. That's the only way that ancient people would have been able to see these images and carve them on rocks. And they didn't have the technology to do the experiments he did, nor was he looking for anything like that. So, once again, it goes back to we're trying to explain phenomena from the past with the best tools that we have today. And, I don't want to get too deep into Dr. Peratt's story, but he ended up leaving the group and denouncing them guys and this and that. They got into it. It's like being in a band and you're the lead guitarist and you decide you're going to go out on your own. He had a massive heart attack too. I think he right now works for the Jet Propulsion Lab. But those papers were eye-opening to me too, because I'm like, well, what the heck's going on? Well, how could that happen? Well, from an electrical theorist standpoint, they're going to say that comets are charged. They're not dirty snowballs, or they're just not free floating objects that are just orbiting around the sun. They're going to say there's charge to them. So then if you have an invading body in our solar system, then the sun being electrically charged is going to react a certain way. The gas giants, which are also, they're going to say ionized plasmas, they're going to react a certain way, and it's going to cause havoc and chaos. Now, he may not subscribe to Dave Talbot's ideas. I don't think he does, which is fine. But they're looking outside the box, and it is outside of the mainstream scope. I don't think Dr. Peratt is just some Looney Tune, and his papers are peer review published through the IEEE, which is the International Electrical and Electronics Engineers. They're plasma physicists, yes, and they're electrical engineers, yes, but it's hard for them to get astronomers and astrophysicists to participate and come to their conferences, things of that nature. Right back to, you have this way of looking at it. You're going to say, okay, we can predict 100%. They're going to say, well, no, you can't. We have a little better grasp on that, but it will require the electrical discipline to be introduced to children and college students when they're in the fields of astronomy and astrophysics. So it just kind of opens a can of worms, so to speak, because I'm not going to say you're wrong and you're not right now telling me that I'm wrong. It's just that you know, we're looking at the ancient past, and I think that's what causes the problem. That from a uniformitarianist viewpoint, none of this stuff would even make sense. And I'm not trying to deviate from the science, because boy, we could really talk about it. I wish there was somebody else from the group that could come on this as actually a scientist, whether it be Jim Wenninger, he's an astronomer, Neil Thompson is an electrical engineer who just really, really knows his stuff. They're better than me at this stuff. I'm more into the mythology and in the history end. But then, when you look at from the methodology of not so much of Velikovsky, because you're right, he probably was more of a fundamentalist. Sure, I don't have a problem with that. He's going to try to explain catastrophe, the sun and moon standing still. That we know that's also in the Popol Vuh. And then the Lord sent hailstones down and stuff. Well, people that are writing this stuff, and I'm not going to debate whether or not the Bible's a primary source, but the people that are writing this stuff, and they have symbols that go with the language, it can't be like super preposterous, because we have the enigma. And I'm sort of introducing another topic, because we could go on for this stuff, man. It's so interesting for days, weeks, months. And I'm just going over some very old notes, and this book is probably 10 or 12 years old. But for instance, because they're going to say you have to look at their methodology is the symbols, the language of the symbols, look at the petroglyphs too. You're going to look at everything. You're going to include everything. You're not going to look at it regionally. You're going to look at it globally. So they would say, why would ancient people refer to the planet Venus as a serpent or a dragon, a chaos monster, a torch in the sky, a long-haired star, a bearded star? The Sumerians or Chaldeans would say that Inanna was the lady of life, a dragon-like flame in the sky. She deposits venom. She rains down a fan fire upon the nation. She's a roaring storm. She devastated the land. Mankind comes before her with fear and trembling at her tempestuous radiance. Ishtar is a shining torch of heaven and earth and rains down flames of fire. She's known as a witch star. Sekhmet in Egypt is a Uraeus serpent. She's described as a flame of fire in her tempest. She's a star scattering its flames of fire. The fear of me is in the hearts of them. They awe at me in their hearts. The coffin text says no one can approach her at all, and the streams behind her are as flames of fire. That's where they're going to say, hey, wait a minute. I personally don't look at the sun in the sky and ever picture a serpent around it, a Uraeus serpent, flames of fire, or Venus. Venus being is the brightest planet in the sky, and you could easily pick it out the sky. I don't see it that way. Do you? I'm sure you don't see it that way either. But they're really getting descriptive about it. And then their behaviors as people, I mean, damn, okay, we're going to have a ceremony today. Let's get this child right here, and we're going to sacrifice this child. Damn, we're going to cut this person's heart out, and that's really bizarre. So I never had an explanation for that. Maybe these scientists are 100% wrong. Maybe they're not. Maybe there's some tangible proof because of their predictability. You may say no. They're going to say, well, we're not going to, we don't see it that way. We have to try to explain through science how and why these people behave this way, but we can't do it with our current science models because it wouldn't make sense. So I guess that's the other level to it, to whereas, you could disagree, I could disagree. And at the end of the day, these ancient cultures of people are behaving very bizarre. They seem to be psychologically off kilter. They have very weird ritual practices. Man, like we can't explain that stuff through science. So we have to do what? I mean, how do we explain it? Because I'm like, well, damn, Venus doesn't behave that way. The sun doesn't behave this way. Mars is supposed to be the great warrior. Mars is a barren planet right now. It really doesn't have much to offer. Jupiter is the largest planet in the solar system. The Juno spacecraft did, obviously a lot of great work and still doing great work there. You have Cassini with Saturn. We seem to be baffled at certain things. I mean, I don't know if you agree with that. These guys are going to say that the ancient solar system was totally different and humans remembered it, which is why we're pretty much in an insane asylum and we think we're sane right now because of the ancient past. But then even when you flash forward, Gunnar Heinsohn may not mention that stuff, but he's going to say, hey, there was a catastrophe that ended the Imperial Roman Empire not more than 1,200 years ago. And we're really fooling ourselves because when they put the history back together, they put it together in a sequence rather than it being contemporary with each other. So, I mean, I don't want to go too far, but you kind of get where I'm going. I don't know if you're familiar with Dr. Peratt's work.
At least not by name, but let me just at least go through the things you mentioned, just because I can at least address the claims.
Yeah, go ahead.
Before you start that, Dr. Adair, I just want to ask real quick. This is a bullet cluster that I found.
Yes.
Yeah, I just wanted to put that out. Okay, go ahead.
Yeah, and just quickly, the coloring we're seeing in the bullet cluster, it's a false color image where the red and blue are to create to look at basically if I remember correctly, it's the X-rays that come off, and it's due to when the clusters hit and they compress gas. When you compress gas, you heat it up. Something you probably even know just from a bike pump. Start pumping a bike pump, it gets hot, and one of the reasons is you're compressing gas. That's just ideal gas law.
Okay.
So we can see that basically some parts are cooler and hotter than others. And the weird thing is where that heating and cooling is happening, or that the hot spots are, isn't necessarily where all the mass that we can see is. The biggest amount of compression seems to be happening where visible matter isn't, which is exactly what the dark matter thesis would suggest, that there's matter there that we can't see that has that gravitational effect compressing the gas. Elsewhere, there's less of it. And this is, like I say, one of the proofs that many dark matter theorists will point to and say this is something that like modified versions of gravity or other theories haven't been able to explain well. All right, but anyways, a few things you had mentioned along the way. So first off, when it comes to like say comets and trying to explain comets, it's not like a point of maybe it is, maybe it isn't with comets if they're charged or not. We can tell where they're not. We've literally sent probes to go into the tails of comets to measure what's coming off them. We did that back in the 80s with the Giotto probe. We've done that with other probes since. We've been observing them for years. We can tell they don't have significant electric or magnetic fields. So to say that they're charged objects is basically to just deny the measurements that we've actually had.
Are they ionized at all? I'm just asking, are they ionized at all? Is there any, from what your what the data would say, it suggests, are they ionized at all?
So one interesting thing actually with comets that you'll actually notice in their tails, they usually have two different tails and even of different colors and with different trajectories. One of the tails is actually ionized gas. It's being ionized by the light and the solar wind. And then there's a dust trail that's coming along the original trail of it. And that dust isn't being ionized. And we can see it's not being affected then by electric fields to push it in any sort of significant way. So we can actually see that a lot of the stuff the comet leaves isn't charged, and the stuff that is charged is because it's literally gases being ripped apart by the high energy photons from the sun. Also, it's worth noting that not every object that comes by zipping towards the sun will actually become a comet, which then also goes against things. So, for example, when I watched some of the stuff from the Thunderbolts project trying to explain comets, it's saying that the comets have highly elliptical orbits, and when they're very far away from the sun, they have a different voltage than when they come closer, and then that voltage change is then supposed to explain them starting to become incandescent. Problem is, we've had many objects come from even deeper space and not do that. Just a couple years ago, there was the object called Oumuamua that was actually from completely outside of our solar system.
Right.
Its trajectory means that it's shooting into the solar system, shooting out, and is never coming back. And it never formed a tail at all. It never became a comet.
Right.
So that is completely unexpected by this idea that somehow there's this big electric field going from one end of the solar system to the other, because now one of the predictions you'd expect doesn't come true. So we have direct measurements from the comets. We can tell the material coming off them. We have sent probes behind them to actually collect material from them, and we are not detecting the things we'd expect if they are charged. As far as I can tell, it's falsified. And besides, even if comets were charged, we would actually also notice something else, that the key thing that why, for example, why is the Earth not electrically charged? Why does it have no net electric charge?
How would we? Because I'm going to ask questions. How would we know if it had a net electric charge or not? Could we measure? Because they would say Christian Birkeland, his experimentation was pretty dead on with that many years ago with the auroras. So how would we know if it has a net charge or not? How would it be measured? Would we measure it and buttress it against?
We measure it with its electric field in the same way we would measure any other electric field, and we've had instruments that have been able to do that for what, 2 centuries?
Something like that.
It's not brand new technology. We've been able to measure electric fields for the longest of times.
Right.
So if something is electrically charged, we are going to be able to notice it when we send probes up there and measure it. And also, just to note, like, Earth does not have a net electric charge, and there's a simple reason why. If Earth did have, let's say, a positive charge, anything that's negatively charged is going to be attracted to the Earth, which then means the 2 charges are going to add together and they're going to cancel out.
Okay.
The natural thing for charged objects to do is find their opposite charge, collect together, and then become overall negative or neutrally charged.
Okay.
So for comets to just stick out there and become charged and then not attract anything else to then become neutrally charged is completely unexpected.
We have hold on 1 second, Sean. We have a super chat that's been waiting for a while from Liren.
I don't see a chat.
Thank you for the 6 shekels. It should be on your screen, Sean. I
don't see the chat. It says private chat.
No, that's not it. I displayed it on the screen anyway. You should be able to see it.
Oh, okay. Look in the comments.
Why is a comet seen as a bad omen across cultures?
That's because I had some question for Dr. Adair, because that was an interesting piece he just gave. But that is true. I know that. I definitely know that whenever people would see a comet, a king is going to die. You know, like, that just jumps out at me. Like, I don't know, man. Why are they afraid of comets? I would say because of obviously what happened in the ancient past. They have a fear of the comets. If the Venus is being described as a comet, I mean, Venus is weird. I know Venus is weird, man. Venus has a magnetotail. Yeah, I mean, we can get back to Laren's question. I agree that the ancient cultures had a fear of comets. Now, even back to the comets, you know, it was Walt Thornhill's prediction of Temple 1, that projectile that they launched at Temple 1. It blew me away. I contacted him, and, you know, I have the books and stuff, and I was holding up the books, and then he friended me on Facebook, because you couldn't really give him a friend's request many years ago. But I was blown away, and I'm like, okay, that dude got the prediction down to the T. If you're going to shoot a copper projectile at this comet, he's saying this is what's going to happen. That copper projectile is going to arc before it impacts the surface, and then it will not impact the surface like you think it's going to, because it's ionized, it's charged. And what he said actually happened, and I was like, damn. I mean, that's wow. I mean, I've seen leader strokes with lightning rods. We don't really have a lot of them, where if you have a lightning bolt coming down and then you have a lightning rod, you'll see a leader stroke come up to meet they would say that the Earth's crust is negatively charged, and then they start to talk about dipole magnetism. And I don't want to sound weird, because then they would say they're going to give a different explanation as to what's inside the Earth's core than maybe you would, but then we're more negatively charged on the surface, and that maybe inside of the Earth, if I'm saying it right, that dipole magnetism is at play. That's Walt Thornhill's thing. I'm not him. I can't really, elaborate on it. I know that that prediction was right, though. I'm like, well, damn, he got it right. Did he guess it right? I know how he got it right because I looked further into it, and I'm like, whoa, I see where you're getting this from because of what happened with Shoemaker Levy 9. And I remember that. And we've used that video footage. I'm like, yo, the explosion on the backside of Jupiter was huge. What caused that? You're not going to sell me on there was no explosives in it, no TNT. I might be being a little silly, but that was devastating. And I'm like, how did that happen? Now, there might be a different explanation from a mainstream scientist versus an electrical engineer. Well, then where do we meet? Where who's right, who's wrong, who's more right, who's more wrong? Can both sides work together to problem solve rather than, arguing, damn, I know Walt Thornhill got that right, but he got his clues from the Shoemaker Levy 9 incident.
Okay.
I mean, that's
so I think in some ways you drifted away from the original question, so I want to jump back to the super chat first.
Yeah, go ahead.
Because
get down. Yeah.
Let's money's being thrown at here. Let's address that very well. So, Liren, it is true that many cultures indeed have these negative connotations towards comets. However, it's not universal. For example, in sub-Saharan Africa, the Kung tribe that's mentioned by Carl Sagan in his book on comet actually has a positive view about comets, that when they're seen, this is supposed to be a positive omen. So it's not quite universal. And also we see in many ancient cultures that basically how the comets do get interpreted will kind of depend on how expedited it could be for to what ends. So usually you could say it's a bad omen, but you can say it's a bad omen for those guys. It's great for us. So, for example, and of course, there's often metaphor for it. So, for example, if we go to China, the word for a comet in Chinese is a broom star, huixing. And so they use that as the metaphor that the broom is coming in to sweep away evil. So their understanding for it is the thing looks like a broom, and from that metaphor, what do brooms do? They sweep away dirty stuff. So if they're using these sorts of metaphors to explain what comets do and why they do these things or what they're supposed to signify, that's how we should probably be interpreting it, rather than saying there's some sort of innate memory in all humans that isn't in all humans, because we can find examples of it not existing there. And also the immense flexibility that people will take in interpreting comets. Just in our historical records, we had the comets that were seen at the birth and the coronation of Mithridates VI. And that was used in his propaganda to say how awesome he is. And he was basically coming in as pretty much a savior of a Zoroastrian type, because they used that kind of imagery in his propaganda. When there was a comet seen after the death of Julius Caesar, that was claimed to be, oh, that's his soul going up to heaven. So what does a comet mean? It's whatever people needed it to mean at that time very often. And similarly, I'll also give another example of a comet that was seen in even more historical times. In 1630, there was a comet that was first seen at the daytime, and it was actually interpreted as a wonderful sign for the newly birthed son of the king. So it was seen during the reign of King Charles I, who, if you know your English history, does not end well. But his son, Charles II, when he comes to the throne, he's being touted as basically the biggest thing since Jesus. There was literally a star at his birth. He is just that awesome. He is literally as big as Jesus. What was that star seen at his birth? It was a comet. And we definitely know it was a comet because the Italians also wrote about it and said how it's this, terrible plague comet. The English are looking at the same object and saying it's a sign for the birth of our new prince. The Italians are looking at it and saying it's the onslaught of the upcoming plague.
Because I'm looking at the comments now. So what I'm seeing Liren writing from Dave Talbot's comparative mythology methodology. Definitely myths and cultural content is going to change over time. The archetypes, you want to try to use the oldest that you possibly can, because they're going to contradict themselves eventually. I see Venus sometimes looked at as a morning star, could be an evening star. Mars could be a morning star, an evening star. Sometimes deities even flip-flop. I think Michael Heisner's his name. He's going to say Marduk is Jupiter. Ev Cochran's going to say, well, no, archetypically it's Mars. It gets a little tricky. So I can understand what Dr. Adair is saying, to whereas, over time, and what Laren's even saying too, that over time, their viewpoint on things are going to change. It doesn't dismiss the fact that at one point people were definitely afraid of comets, and their understanding may have changed over time. We come from very superstitious background in the last 400 years even. I mean, dang, King James, I read the book Demonology, and I was like, this guy, he was afraid of, elves and fairies and all kind of weird stuff. Like, we have a superstitious background where we might see a dust devil and go, oh, my goodness, the wrath of the Lord is coming. But now I don't think we would do that. I wouldn't do that. I understand Dr. Adair's viewpoint, as well as maybe even Dave Talbot's viewpoint too, on the same thing. It's stuff that could be still openly discussed. I know, looking at the Kojun people from South Africa, their symbols, I've seen them draw symbols in the sand, and they look very archetypically the same as symbols from Rome, even Egypt. And I'm like, well, even though they're in the southern hemisphere, maybe they saw the same thing in the sky, possibly. I think too, looking at the symbols, let's say even in ancient Egypt, and I'm not trying to just move around and stuff, but the word Kem Budge said it means city or land or whatever. And I think it's Eric Hornung. I have his books too, that it means region. Well, it's a circle with an X in the middle of it. The Mesopotamians may have drawn it a little different, but the Shema symbol is very, very similar. The word placenta in Egypt, why it's placenta, I think was Budge, is a circle with lines through it. Well, in Eric Hornung's translation of the Duat in Tutmosis III's tomb, in the second hour of the story, I think it was Ma'at is in the solar bark, and then that image is in the solar bark with her, and has a crescent on the bottom, and it's the round circle, and it has lines through it, and his translation is that's the moon. The moon doesn't look like that. The moon has craters. We know it has craters. We see it has craters, but that's his translation. The Electric Universe people, those guys are going to look at it different. Like, what is that? Why would an ancient culture draw this circle with these lines in it? It looks a lot like Jupiter to me. I don't know if it's Jupiter or not. I'm not even going to speculate and say it is. But then when you go to a guy like Dr. Peratt's work, and he talks about synchrotron radiation, the symbols that match the petroglyphs to about, I think he said 40% of the petroglyphs match his synchrotron radiation experiments. They'd have to see it to be able to draw it exactly, especially like the stick man with the two concentric circles in his arms up, which is the Kananga mask in Dogon lore. They use it for juju magic in Africa. It's an amulet, but we see it all over the earth. I don't think people were walking around and was like, hey man, I'm going to draw this stick figure. I'm from Africa and you're from Australia. Check this out. And I'm going to draw this stick man with these two concentric circles. That's under investigation then, from his science papers and stuff. So, the Electric Universe, and I'm not going to sit up here and say that these guys got all the answers and everybody in the mainstream is just wrong. I'm not going to do that. I'm just going to say that these things are up for debate and argument, and we've got to try to use the best tools we possibly can to try to solve these problems, even if it means that it may not be coming from mainstream astrophysics or physics. It may be coming from the plasma physics and electrical engineers. Possibly. I mean, anything's up for possibility for me, especially coming from, like a Big Bang way they taught us in school, and universe expansion. Halton Arp's name comes up a lot in conversation. I mean, interesting, intriguing. How do we solve these problems with our current understanding of cosmology? I don't think you can. But it's not to say that guys like Dr. Peratt or Dr. Donald Scott or Wallace Thornhill, because they're predicting really, really well, is going to kind of overthrow the science establishment. And I think that causes a problem. That may have caused a problem with Dr. Peratt along the way. That's another story, though. But still, right. We're just trying to talk and use the best tools we possibly have to try to solve these enigmas and these issues. And those guys are going to say they got a great deal of it figured out, but it's through non-standard means. And then back to what you're saying about comets, because that's they're, those guys will come on and say, no, Dr. Adair, cometary tails are ionized. Like we have meteors that come into our atmosphere, they discharge. They're going to use the word discharge. The language is a little different, and they're going to, what some people would say is, burn up before they impact the surface of the earth, because they're electrically charged, and they're trying to seek, I'm going to say, hope I'm saying it right, those guys would crucify me, but that they're seeking some type of electrical equilibrium with the environment they're in, opposed to the environment that they once were in. So I mean, right, I'm just here to just kind of guess add food for thought. You know what I mean? Like it
Well,
becomes
I can understand food for thought, but when it comes
yeah,
down to it, if there's going to be a claim, then you
yeah,
have to say what's the evidence for it, and if the evidence is against for it, then you got to drop it like it's hot.
okay,
So when I say that, for example, we're able to measure electric fields around things, and we could tell comets don't have a net charge unless you can, show me a paper, show me a measurement that actually happening, then there's
okay,
nothing to discuss, unfortunately, on that point. It's just a straight up measurement. Now, you had mentioned that the impactor on Temple 1, that was supposed to be somehow evidence. I don't think I understand that. And I tried watching the video about
right,
that and with about Shoemaker Levy 9 hitting Jupiter.
right,
The thing is, there's nothing there that any physicist would look at and say, this requires plasma physics to explain. It's thing hits, stuff pops out, and the stuff is lit up because, for example, the light of the sun in the case of the comet, you shoot a bunch of dust up and now the light of the sun can reflect on it. Yeah, you're going to see it pop out. There's nothing that requires us to rewrite physics to say, oh, debris.
yeah. I don't think.
And
And
if it really is
go
the
ahead.
case that we're seeing some sort of deflection of the probe, then I would say, okay, if that's the case, how are you actually measuring that to actually show that that's the case? Because if you're not actually showing it, you don't know it. You can't just say it looks like it. You need to say, how are you measuring? How are you showing that you actually know that that's right? That is against the expectations of what all the other physicists who are running the probes and getting that. Because otherwise, if you're just making claims and you have nothing to back it up, it should be dismissed.
Well, yeah, but then I think, okay, because I'm looking at Laren's comments. So then he's asking questions. What was the probe that blew up TNT? Either we're talking about Shoemaker Levy 9 or the projectile was shot at Temple 1. It was a copper projectile. So Walt Thornhill, he's a physicist. He's a classical physicist, though. I don't know if you're theoretical physicist. There's a guy in our group. God bless him, because I don't know what's going on with him, because he lives in the Ukraine. His name is Eugene Bagashoff. He did videos about Oumuamua. I would like to hear what he has to say. I don't think he's an EU groupie by any means, but the copper projectile is shot at Temple 1, and they thought, I guess, then it was going to hit the comet, and it was going to hit the surface, and water was going to come flying out. What didn't happen that way, it arced, then there was a huge explosion, and there really wasn't an impact to see. It didn't make a crater or anything of that nature, because they're going to say that comets were electrically excavated from planetary or hard surfaces. They may also say, and this is like, how are planets even formed? How are suns formed? Well, there's going to be one explanation on one side, and they're going to kind of rely, I think, on Halton Arp's work.
Well, if you're going
You
to
know what I
mention
mean?
how did the sun and earth form, then we can just jump to that and
Yeah,
say
like,
on the electric theory, it can't happen at all. Like full stop.
well,
Electric
they
theories
say
can't explain the accretion of planets.
they're going to say we never saw that before. That's what they're going
It's
to
not a
say. We
matter of
never
seeing
saw
it,
it.
is we can do the basic
So
physics.
can we do it in a lab? Are there any clues then to prove that gravitational accretion it works? Because what they're going to say is, okay, and
We
I'm
can
just
watch it right now, actually. We can
oh,
look into stellar nebula and we can actually see the formation of planetary systems.
okay. So then what they'll say is they're going to say that from supernova explosions, the prediction on the mainstream side is there should be clumps. we're seeing filaments, and we're seeing the planetary systems and the suns and stars, etc., on these through these filaments. Another gentleman in this part of the Sapphire team, who's an astrophysicist, I forget his name. He's like 6'7", it looks like. He'll say when we look through X-ray telescopes, we can see elements, but they're not like scumbo in a soup pot. It's structured, like it's not just random. So they're going to say it's because of it's electrical event versus mainstream
Well,
saying it's, you know what I'm saying? It's
they
like two
can make all
different
the claims they
terminology.
want, but here's the problem. We know why things fall to the earth, and we know that if it was an electrical explanation, it would fail. That explanation would fail because, first off, the earth has no net charge. So how much can it actually pull to it because of the electric force? Absolutely nothing.
Well,
Moreover, if it's actually pulling anything towards it, that force will get weaker and weaker because it can only attract oppositely charged objects. So if you have a positive and negative charge, they will attract. But once they come together, that net charge is zero. And so now it provides no electric field and no electric force at all to attract more things. Conversely, in gravity, all things are attracted to each other. So you get two clumps of mass together and they come together. Now their gravitational force is stronger, not weaker. The exact opposite of what an electric hypothesis would say. So quite simply, how the planet Earth can form is impossible on an electromagnetic theory. Not just difficult to explain, literally impossible.
well, again, okay. See, because it's terminology, I'm trying to follow what you're saying. So gravity is an attractor or repulsive? Is it attractive or repulsive or both?
It's always been attractive. All
Only
examples we have found.
So then, why isn't the Earth being pulled into the sun then?
Well, now that is going to get into some more proper physics. So why does the Earth, why does the moon not just fall directly to the Earth? That's because the moon also has forward momentum. The Earth's gravity provides a centripetal force, which is what causes it to then have circular motion. The same sort of thing happens if you have, say, a rock on a string and you're spinning it around your head. What's the force is acting on the rock that makes it go in a circle? That string. Well, why isn't it just flying directly right into your head when you're pulling that? Because it also has that forward momentum, so it makes a circular path rather than just a straight path. It's exactly as expected on momentum conservation, and in this case, the force of gravity providing a centripetal force for the Earth going around the sun or the moon going around the Earth.
Okay. Well, that's what we were pretty much taught growing up.
And the thing is, we can actually show why that is true right here and now with just some basic math. In fact, this is an interesting bit of history. So when Sir Isaac Newton was trying to come up with his idea of what gravity is and explain it with a force that falls over as 1 over distance squared, he then tried to say, okay, I'm going to try to explain the falling of apples traditionally and the moon with the same force. How does he possibly do that? So he can measure, thanks to actually the work of Galileo Galilei, what's the rate of acceleration of objects here at Earth's surface level. And today, you'll read that next textbook of about 9.8 meters per second squared is the rate of acceleration. So Newton says, okay, suppose that force that is causing this is something that falls off at 1 over distance squared. So that means if that force acting on the moon is coming from the center of the Earth, it should be weaker. What rate of acceleration should we expect for the moon to have if that's the case? Now, since Roman times, we've actually known how far the moon is away. We can actually do that with trigonometry. We've literally known for about 2,000 years the approximate distance from the Earth to the moon. And since Greek times, we've also known the size of the Earth. So Newton literally has these measurements in his textbooks, and he can say, oh, the moon is, I think, like 60 Earth radii away, is how I think his textbook would put it. So he would expect that if it's a 1 over distance squared force, then the acceleration on the moon should be 1 over 60 squared, what it is at the surface of the Earth. And since we know what the acceleration of the moon is going around this Earth, because we know how long it takes to go around the Earth, because we know it's the size of its orbit, he does the math and it says, hey, it matches exactly my theory.
Well, now, because I'm listening and I'm looking at the comments too, because Laren is really putting a lot out there. He's mentioning Sapphire. I think you mentioned Sapphire in one of your comments before. Sapphire may or may not be peer reviewed with in physics journals, but they may have peer reviewed it through the IEEE. I'm not sure. But Sapphire, he's saying accretion and transmutation are easily explainable because we saw it on Sapphire, and we did. They transmutated elements using an anode and atomic hydrogen, and they repeated it over and over and over and over again. So it's like,
And
okay,
they've published that in what physics journal?
okay, I don't think they're interested in that. And we talked to Montgomery
And
Child.
that's why it needs to be thrown in the trash.
Hold
If you
on,
can't
hold
show
on,
it,
hold
no,
on,
no,
hold
no.
on,
If you can't show it,
hold on,
you don't
hold on,
know it.
hold on. Because what they were doing, they had to get patents on the equipment that they first used. First of all, first and foremost. So we talked about it. I mean, that would be good to have Monty Childs on to talk to him or any of those engineers about their experiments and stuff. So everybody wants peer review, peer review, peer review. I get it. I understand it. I don't know why, because we asked the same question. And he talked about patents on what they were doing, because now there's a transformative technology they believe is coming from their experimentation. I know they talked to some people at MIT, and they may be up in Canada. I forget what university, maybe University of Ontario, maybe backing them. I have to go back and look. I haven't talked to those guys in years. Nonetheless, they did it, and I'm like, well, damn, you know what I'm saying? Not it
You
being
say they did it, but if they
okay,
can't
hold on,
show it,
hold on.
they can't say they
But
know
they
it.
can show it, and it can be repeated.
But they haven't shown it. They've
Okay,
only claimed it. They
I
haven't shown
understand
it.
that. Okay, I understand that, because I know you guys rely on peer review. I get that. I understand. I understand what you're saying. I don't know why is what I'm saying, and we asked that question, and he talked about patents on what they were using to do the experimentation, and they did it at 3 different scales. So if they're doing it over and over again, they are being very honest and saying, we don't know why it's doing what it's doing. Maybe we need some more expertise from other fields to come together and explain what's happening, because we know we're doing it. We keep doing it over and over again and transmutating elements. But why is it doing that? Doing it? I think he said he doesn't know why, which is very honest. Because
Well, I would think the more honest thing is you need to actually show how you know that they're actually transmuting things. Because back in the 80s, there was a group that also claimed that they had been able to do tabletop cold fusion.
Okay.
Once they was able to be investigated, they found out not even close. No, they were not doing what they claimed. There's a difference between a claim and a demonstration. And if they don't demonstrate it, they can't say they know it. And there's no reason I should believe it.
I personally watched the demonstration, and I was kind of blown away when I saw they blew up a freaking Langmuir probe in the laboratory. Like, damn, it's tungsten. They should that should be able to withstand what they were doing. Pow, they blew the thing apart. Then they're claiming that they sent their anode out to be independently tested for how many labs. I don't know if there's people might claim contamination. I don't know, but they're saying the independent labs are saying this is what elements are on these on this anode. Maybe they were sending um, the microscope images, if you will, electron microscope images. I'm not sure, but they're saying that these labs are definitely corroborating what they're doing. They're showing it that way. Sure, they have videos, but to publish it that way, no, I get your point. I'm not arguing that, but that's one premise that the electric universe people stand on. Now, I don't want to have to read from Dr. Scott's book, but then Dr. Scott is claiming that the empirical method's broken, that you need observation, you need to carry out experiments. If the hypothesis successfully predicts the result of several experiments, it can be called a theory. But if you take the experimental stage out, it's like a three-legged stool. It's going to fall over. So they're electrical engineers, though, that they have a different background. So I can understand their point of view. I can understand your point of view too. So I think it still comes down to, right, like you said, showing and proving. I think the Sapphire team is doing that, but what they got out of it may not have been what they expected. And they're like, hey, this could change how we deal with the eradication of nuclear waste, they're saying. I don't know. I'm not a scientist.
Well, the thing is, if the claim is this is so amazing, it can deal with issues of nuclear radiation, more reason they should have been publishing. And the fact they haven't done that is actually a red flag, not a sign of honesty. I'm sorry. That is so outside of what we expect from honest research. You got to show me how you know it, not just say we blew something up and somebody else said, but we're not going to show you the result from it. But they said we did it right.
They do have the result from it. I mean, it's available.
Where is it published?
What they were saying is they were waiting on patents to come back from their equipment itself. That's why they're not just quick to jump and throw this stuff out there till they get the patents on what they designed.
How long has the Sapphire Project been doing experiments?
Probably, at least from what I know, the last 5 years, I would say. I think it was in the works probably the last 10 years, but the lab wasn't built maybe till 2017-ish, I think, something like that. And then they would show videos of their results and stuff and what they were working on. I don't think these guys are just amateur, hack scientists that say, "Hey, you know what? Let's just X, Y, Z," and they're not in a garage somewhere. They're actually they build a laboratory. They perform the
But the same thing could
experiments.
be said for Pons and Fleischmann when they claim they did cold fusion on a tabletop. They were a couple of chemists. They claimed they just basically
I got you.
upended nuclear physics, and they were wrong.
Oh, I got you. So the same way, I would say, can we sustain nuclear fusion on Earth to prove that the sun is what mainstream cosmologists say it is? Can we do that?
Well, if you're talking about like the experiments going on, like ITER, for example, where they're trying to do sustained fusion for electrical energy, that is still ongoing research. Now,
Okay.
here's the thing, though. We can make predictions about what we expect for the sun to be if it is ultimately a nuclear power system, ultimately.
Mm-hmm.
And the thing is, when we've gone and done that, it's actually come out to be true. Now, in particular, the biggest piece of evidence that is showing that there's a nuclear process going on in the sun is the fact that we can measure high energy neutrinos coming from the sun. So just to give everyone background, because I'm not going to expect everyone to be a particle physicist, neutrinos are a kind of subatomic particle. They were given the name neutrino to be a small neutral particle. They have no electric charge, and they were originally hypothesized in the 1930s to explain issues that they were seeing in nuclear decay. It was basically that it looked like without these particles, momentum conservation was lost, and people didn't want to throw out basic physics. So they hypothesized there's another tiny little particle that's being let go. And about 20 years after the predictions, it was then finally detected. And so these very tiny particles are given off in nuclear decay and other nuclear processes. So the idea then is that the reason the sun is glowing incandescently hot is that at its core, under absurd levels of pressure, largely hydrogen gas has basically had all of its electrons stripped, and the pressure is so great that we can actually get protons so close together that they will actually undergo atomic fusion. And in that process, it will release neutrinos.
Mm-hmm.
We then say, okay, if it's supposed to be releasing neutrinos, and we also see the energy output of the sun, well, there are models of the sun that would predict how many neutrinos there are. And we've been able to detect solar neutrinos for decades. And after a lot of work, we've been able to discover interesting new things about neutrinos and see that indeed the neutrinos coming from the sun is at the level that is expected. Now, conversely,
Okay.
an electrical hypothesis predicts an exact number of neutrinos, 0.
That's not true though. It's the
It's
ratio.
not a nuclear process, so
No, no,
it
no,
is
no.
fundamentally
It's
wrong.
no, because they're saying the nuclear process is on the surface, not deep within the core. That's where
Then we should see gargantuan gamma rays coming from the surface of the
so
sun, which we don't.
then what they would say, and then I have this question too, because I was told whenever I was in high school, because I wasn't a scientist, I didn't take any science classes, I only took one math class in college. Thank you. That our bodies are being bombarded with millions of neutrinos at any given point in time.
Mhm.
Have we detected the amount of neutrinos that's necessary for that to be the case? They're going to
Yes.
say no. They're going to say no. That
They're wrong.
Neutrino
They're
detector
absolutely
is not
wrong. The
millions
papers have
of
been published for
neutrinos?
decades.
Okay, so then they're lying. Then they're just making it up and saying, "Oh, we're just going to lie."
Wrong. I
They're
think
saying
they're
the
wrong.
ratio. They're saying the ratio of neutrinos is wrong. That they require neutrinos also, but it's a different ratio. I don't know exactly what their ratio is, but they're saying
So
that
I
the
think I know what they're going after. So I'll just give a little bit of background, because the original experiment to detect solar neutrinos did actually go against the original sun nuclear fusion hypothesis. Here was the issue. So the original experiment done in the 1960s literally hollowed out an entire mountain and filled it with chlorinated water. And they needed to have basically an entire mountain's worth of chlorinated water, because neutrinos are so tiny and so non-interacting, they can basically go through the entire Earth like it's not even there. They're effectively ghost particles. The number of collisions is so rare that the only way you're going to detect any significant number is have lots of opportunities. If your chance of hitting a target is small, what you need is lots of targets. So in the 60s, the first experiments to try to measure those solar neutrinos came back, and they got 1/3 the expected number of neutrinos.
Okay.
Now, that was back in the 60s. And since then, people realized that there was actually a fundamental limitation with the experiment and the neutrino physics. That experiment could only detect one particular kind of neutrino called the electron neutrino. And we now actually know that not only are there multiple kinds of neutrinos, but they can oscillate between each other. So the sun generates electron neutrinos, but because they are able to oscillate between all three, by the time those neutrinos get to Earth, they've become all three different kinds. So that original experiment could only detect one. And since it's now only detecting 1/3 the expected, that kind of makes sense. Since then, we have developed new neutrino detectors that can detect the three different flavors of neutrinos coming from the sun. And once we have done that, it now actually matches the predictions that we expect from the number of solar neutrinos.
So what they would say is that you guys moved the goalpost because now there's different flavors. That's what they'll say. There's different flavors when there weren't supposed to be different flavors originally. And that is essentially falsifying the claim. That's what they'll say. They're not going to.
Well, here's the thing. Here's a few things that would be said to that in response. One, we've actually known about flavors of neutrinos for a long time. It was not an ad hoc thing. It was a discovery in particle physics that different kinds of neutrinos existed. For one thing, it happened because we discovered there are different kinds of leptons. So the electron is a kind of lepton, and the muon and the tauon are heavier versions, basically, of the electron. They're also unstable, so they decay very quickly, which is why we don't have like piles of kaons. You can't go to Ace Hardware and get a bunch of muons. They last about a millionth of a second.
Yeah, because they would say like because Laren is making comments because I haven't even talked about this stuff in years, but nonetheless that you're changing the racetrack so the car stays on the track because the car already went off the track, and I get it, but again I'm not a scientist. So, I'm just more or less asking questions because I've heard these answers and explanations from other people. Because they're also talking about in the back chat. I'm seeing they call it the back chat. They're talking about. I know the temperature of the sun is inverted, so we're looking at the sun and okay, we'll just use 6,000 degrees on the surface. Then you go to about 2 million within the heliosphere, if I'm saying it correctly. But then when the sunspots form, it's cooler. We don't. Where's the 10 million degrees coming from? Where's the immense pressure coming from? I think the Sapphire people just kind of simplified it because if these guys are claiming it's an anode, and I know there's going to be questions from a mainstream scientist. Okay, where's the particles being drawn from? Of course, there's going to be a lot of questions, but I think they took a much more simple approach to solving the enigma of the inverted temperature of the sun. That would probably make a little more sense based on their experimental data than still the 10 million degree convection oven in space that's burning. And oh my goodness, one day the sun might burn out and we're all going to die. I'm being silly a little bit, just trying to add some humor to it. But
actually, your bit of humor actually brings up something a bit interesting.
It's so, again, those are the things that they talk about in their books, and they're going to say, well, we're going to use a much more simple approach and go back to the drawing board. If the prediction comes back wrong, we're not going to sway and we're not going to move. We're going to say, okay, the prediction's wrong. We have to go back to the drawing board, erase the chalkboard, and start over again. They're saying we should have been starting over again time and time again instead of making adjustments. In other words, their claim is that mainstream science draws a conclusion and then fits the pieces of the puzzle into the conclusion as they see fit to make it work, rather than letting the scientific method itself draw the conclusion. That's what they're going to say. They're going to say that it's, they're going to say that. And again, maybe it's because of their disciplines, being electrical engineers primarily, some physicists. That's what they're going to say.
Well, they can say all the things they want, but if we go and do the experiments, and here's the thing, again, the number of neutrinos expected from an electrical sun is exactly 0.
They're not saying that.
I know they don't say that, but they're wrong.
On the surface. Okay,
they're fundamentally wrong.
And that's where it comes down. This would be interesting to see an electrical engineer talk to you, because I'm not an electrical engineer and I know basics, very, very, very fundamental basics. So I can't go too deep into it because that's way outside of my scope. I'm a communications media guy. That's way outside of my scope.
But here's the thing. I've also looked in the literature. They don't have an explanation for neutrinos. You mentioned them saying there's fusion on the surface of the sun. So one, it begs the question, why is there fusion on the surface of the sun, and then somehow there's not all these gamma radiation being left from the surface of the sun, which you would expect. So the reason we think there's nuclear fusion at the core of the sun is because you need the immense temperatures and pressures at the core of the sun for that to take place. And now when I say temperatures and pressures, the density at the core of the sun is denser than that of lead. And the temperature is over 1 million degrees. And it doesn't matter which scale you use, it's over 1 million degrees. So it is absurdly hot and high pressure, which is not what you have at the surface. It's not possible to get fusion at that surface. And if there were fusion at the surface of the sun, we would see the effects of extremely high energy gamma rays, which we don't.
Yeah, I don't think there's fusion. I'm the language. I just said nuclear reactions. Nuclear meaning small. That's the only way I'm looking at the word nuclear, is meaning something that's very small. It still doesn't account for 10 million degrees to 6,000 degrees to 2 million degrees. Again, I don't know how that works. That's like, okay, can we prove it through experimentation? That's what they're going to say. And if the answer is no, then maybe that's not how it's working, and we want to know how it really works.
The way the scientific hypothesis would be, okay, if we're going to say there's some sort of outside electric field that is generating this effect, then we'll say, okay, where are the other effects expected from a large external electric field? And one of the things you would expect then, because first off, we know the sun is shooting out charged particles in the solar wind. If there is this gigantic electric field to act on the sun, then we should be able to see that positive charges will get flung in one direction, negative charges in the opposite direction. That's the expectation if you're saying there's a giant electric field driving the sun. We don't see that with the solar wind. We don't see them positive and negative charges being shot off in different directions. So that's a falsification. There isn't this extra giant electric field.
I don't think they ever claimed there's positive and negative charges that dissipate or shot out from the sun. I don't think they've ever said that or made that claim.
Well, that's the solar wind. The solar wind are charged particles.
And they would say that terminology would be Birkeland currents. That the terminology is wrong. I know that I don't know if two hydrogen atoms fuse together to produce a charge. That's like using a non-electrical explanation to describe something that's electrical. That's what I was told it was, and I'm like, okay, can you show me that in the laboratory where two hydrogen atoms fuse together to create that positive charge? If the answer is no, then maybe it should be explained from a purely electrical point of view, or plasma point of view, rather than mix matching. If you kind of get where I'm coming from, mix matching terminology and ideas together to produce. It's again what they would say is drawing a conclusion and then trying to work it. So the conclusion, and work the pieces of the puzzle into the conclusion, rather than letting the scientific method.
Well, on that case, what sort of conclusions had led the electric universe people to say there should be neutrinos coming from the sun? Because what I see is a denial.
I'm looking because that would be Dr. Donald Scott's work more so, and I'm looking at it. He'd probably be able to answer it right away. 51, 52. It's something that I have to look at, but they're definitely calling for neutrinos, but not the ratio that the standard model would call for. They mention in the book, he talks about flavors of neutrinos. Talks about Irving Langmuir in this whole. I don't have my glasses on either. I couldn't find my glasses today, people.
Well, here's the thing. I can stop you though at this point because again, electrical processes are not nuclear processes.
And I'm only using the word nuclear meaning small, not nuclear. Okay, because my uncle.
Well, here's the thing: only in the actual nuclear processes that nuclear physicists talk about will you ever get neutrinos to come out. You're not going to get them by using capacitors.
Okay. And again, that's something that's outside of my scope. That's something that Dr. Donald Scott could probably answer rather than me, or Neil Thompson, who's an electrical engineer.
Well, the thing is, I've tried looking for their explanations, and they're either non-existent or no good. For example, saying there's nuclear reactions going on the surface of the sun. That's disproven by our own simple, straightforward observations of the surface of the sun.
Well, so the Sapphire team would say no, that we're getting the same reactions with the anode in the
which laboratory. They can't show because they can't publish, apparently.
But you can look. Okay, I know what you're saying. So I would just suggest looking at their Orion Energy page. They have a page called Orion Energy. They had a page called
which is not peer reviewed, which shows no measurements. In other words, it's absolutely useless. It might as well be reading a press release from the Trump administration. Am I really going to believe it, or going to be a little bit critical of it?
So again, you're just claiming right off the bat that it's total BS because it's not.
I'm saying they haven't done a damn thing to show that they have anything to believe. If they can't publish it, if they can't show it, if they don't have the measurements to back it up, they can't claim to know it.
They could, and I think Laren
could is not done. Could is not the same thing as having done it. I could run a million miles. Have I run a million miles? No, I haven't.
Any of your papers through the IEEE, the International Electrical and Electronics Engineers?
I've actually had some physics papers published with my name on, with my affiliation with MIT.
Okay, but through the IEEE is what I'm saying. They publish through the IEEE because they're electrical engineers. Walt Thornhill's a physicist. He does have papers peer reviewed through the IEEE. I know that Dr. Tony Peratt has papers peer reviewed published through the IEEE. That's where you can find their peer reviews. I don't know if Sapphire did that yet. Again, because
they have not.
Okay. Through the IEEE is what I'm saying. I don't know. I'm trying to look for it.
The thing is, if I was to write a chemistry paper, I would not submit it to a biology journal. I would submit it to a chemistry journal. Okay. If I'm going to do research on paleontology, I don't send it to the Journal of Biblical Studies. Why? Because they're not the experts on the subject.
Dr. Peratt is a plasma physicist. He is not an astronomer, though he worked with Kevin Healy, who was an astronomer and astrophysicist. He's not going to publish his plasma physics papers through the Journal of Physics, I don't think. He's going to go through the lane he's in. So we have this lane, you have this lane, you have this lane.
Actually, no, you publish it in the area where the expertise is. For example,
the IEEE, which is electronics and
papers in a variety of different places.
Okay.
For example, he did chemistry. He did biochemistry research, so he published in biochemical journals. When he did astronomy, he published in astronomy journals. You know, if you're going to do astronomy, you publish in astronomy journals. So if you do electronics, why would you not publish? Why would you publish in those?
I think their accusation is the peer review process is broken. Now that's going to be a strong accusation too, because you would probably, if you are a physicist, okay, and you get a paper from a plasma physicist. Is that outside of your scope? I would think. I would think that
if it's physics, it's physics.
Okay, but then are you versed in electrical law the way a plasma physicist is? No, that's a specialized carved niche. An electrical engineer.
Actually, no. If they're going to be telling me about electromagnetism, and I'm a PhD in physics, then I know electromagnetism. I got here is my textbook from when I was in grad school, Classical Electrodynamics by Jackson. This is what every grad student has to suffer through. And I do mean suffer, because I suffered through this many, many times. So if somebody sends me a paper on plasma physics and they're using equations that don't conform to basic laws of electricity and magnetism, I'm going to say this is not a valid use of known physics. If they're going to claim that our laws of fundamentally, if they're saying electromagnetism is wrong, now they've really got an uphill battle, and they need to do that.
Yeah, I think, again, this gets back to what they would say are politics. They're going to say there are politics involved. I know the story of Halton Arp. I know the story of Dr. Pratt. I'm not even going to get into Dr. Pratt's story because it's pretty.
Here's the thing, though. I've also seen creationists make the same arguments for why their papers about the Earth being only 6,000 years old can't get through peer review. It's not because they're crap.
Right.
Oh, no, it must be because there's a conspiracy. Here's the thing. Okay. I've also submitted papers and have had them rejected.
Okay.
It happens all the time.
Right.
If it was really some big political hoo-ha, there's actually something I can do to show that. I could say, here's the paper I try to get published. Here's the response I got and how it's completely disproportionate and it's just being gatekeepery. Okay. And I could then put that on my blog and say, here is what happened. Mm-hmm. If they don't even try to submit their journal, to even try and get peer review on it, mm-hmm. then they can't claim they're being shunned by the academy. If they're not even trying, that's a problem.
Yeah, I think still, again, it was Halton Arp's story that was very compelling to me, where his papers were rejected. He was not allowed to use telescopes anymore in the United States because of his idea on redshift shifting versus intrinsic redshifting. It's like, damn, so he's challenging mainstream cosmology. The mainstream is they're like, nah, man, this is way outside of my scope, dude. You got that I'm not dealing with that. So maybe there's a bit of I don't know, maybe there's intimidation on their part. I don't know. I know that you notice I keep saying this is what they're going to say. That's not what I'm going to say.
I know that might be what they say, but here's the thing.
What they're going to
Everyone who can't actually show it will say the same thing. How do we distinguish those who have an absolutely genius idea and those who can't tie their own shoelaces?
Yeah. So again, so then that raises the question from their text, from their books, that science is settled, and that's the way we kind of look at it. These ideas from the past, going all the way back to Eddington, are settled. Though we might have to, as Dr. Tyson may even say, tweak some things here and there. It's essentially settled science. Uniformitarianism, Darwinism. The universe is what, or solar system is 4.5 billion years old, and this.
Well, here's the thing: you keep talking about things being settled, or that some things are just the straight up crucible of experiment. If somebody says comets are electrically charged, and we go and we measure one, and it's not, game over.
How do you measure? I don't think we have electrical measuring devices on probes, do we?
Yeah, of course they do. That's how they actually. Oh yeah,
Langmuir probe isn't really a. I don't know of anything that measures electrical charge.
Every single antenna we've ever built is measuring electric fields.
Okay,
that's fundamentally how antennas work.
I thought because you could have two antennas and it could measure charge in between. I think some papers that I've looked through, what this electric universe claim is going to be is the field is around you. You're in the field itself. It's not going to be like I walk outside and it's not, doesn't work that way. It's very, very dense.
If that's what they are claiming, they are now saying that electromagnetism is fundamentally wrong.
No, they're going to say that you have.
No. If that's what they're saying, how electric fields work, that is in contradiction to electromagnetism.
They're saying it doesn't work that way. That you're in the field, the charged particles are everywhere. There's no such thing as empty space. The particles are dense. They can stretch light years. But there's dark mode plasma. There's glow mode plasma. There's arc mode plasma. They're using.
It doesn't matter what the kind of the plasma is. We can measure electric fields, whether it's in a plasma, and if we measure no electric field, it doesn't matter which kind of plasma you tell me it is.
That's interesting that you're saying that, because now I'm like, well, hell, you're telling me at the auroras there's no measurement of electric field at all?
I didn't say anything about auroras. I said comets.
I'm just mentioning that because that's kind of easy, because people see the auroras and they look pretty and everything. So there's no electrical field at the poles at all. Zero.
I didn't say anything like that. I didn't say a thing about that. Right. I said specifically comets. And I said comets, we can tell they don't have an electric field. They don't have a charge.
So then why did the Temple 1 copper projectile arc before it impacted and exploded on the surface?
What's the evidence that it arced?
The film footage. I looked at it and I was like, well, damn.
Yeah, I looked at it too. You know what it looked like? An impactor hitting a snow globe and then a lot of debris shooting up. Exactly what you'd expect.
There was two flashes. One was smaller, the other one was big. There's two, not one. It was two.
So you're basically saying something in the shadows.
I saw two flashes.
Here's the thing. You actually said the probe was deflected, and there is no measurement that has ever been done to show that deflection. To say something like that without demonstration
did it impact the surface and make a big hole in it and water fly out like it was predicted? No.
Who said water was going to fly out? Because here's the thing. That is not. No. That is wrong.
What was the prediction? The
prediction is a lot of debris would be shot out. And the reason we expected that, in fact, the whole point of the probe was to make debris shoot out, because we wanted to get a better look at what the interior of the comet was. And by firing that projectile into it and shooting the debris out, we could get a better look at it and then actually measure it using spectroscopy. The whole point was to make a bunch of stuff splew out like that. That is exactly the purpose of that impactor. So to say that was unexpected when that was the point of the probe,
I didn't see an impact. I did not see an impact. I didn't see a big hole, and I didn't see any spectroscopy that would show me an impact on that comet. I didn't see it. I saw flash, nothing. I didn't.
So you didn't see all the debris pop out, because that's exactly what I saw in the picture.
I didn't see debris. I saw a flash.
You need to look one image forward.
Okay, I saw two flashes. Now I need to see this giant crater hole. And then we can look down inside and see what's in that crater hole. I want to see.
We weren't looking inside the crater hole. That wasn't the point of the probe. The point was to look at the debris that was fired out from the impact, which is exactly what we saw.
I didn't see any debris. Where's the debris? Where did it go?
That's exactly what you were seeing in the flash. And the reason it would look like a flash is because you now have the debris popping out and being lit by the light of the sun. By the way, if this was an actual flash, if this was an actual bright flash, here's the problem. The probe looking at the comet has to basically be adjusted for the amount of light the sun is reflecting off of there. Okay. If there was suddenly a much brighter flash, much brighter than you would expect from reflection, you would expect the instrument to be absolutely swamped with light. Basically, if you were like in a dark room and then all of a sudden you looked out the window, you'd be blinded. That's exactly what we'd expect with the instruments if there was suddenly some sort of flash way beyond what you'd expect from the dim light of the sun shining on this distant comet. So the fact that that flash wasn't so bright that it completely overwhelmed the instrument means it's at the level of brightness as expected from stuff just reflecting sunlight.
So it's a reflection. So we're looking at the same thing. You're a skilled physicist. I'm not. So we're looking at the same thing. I'm just saying what I saw, and you have a really deep explanation to it that involves reflection of the sun and all kind of stuff. I just saw flash, flash. I saw flash, flash. That's what I saw. I didn't see debris flying out everywhere. I didn't see it split in half. I just saw two flashes. That's all. I mean, that's all
No
I
one was
saw.
going to expect this to split in half. No one was
Well, I'm
thinking
just
that.
saying. Yeah, I'm being a little sarcastic. I mean, but I
Okay,
saw what I
okay.
saw. But
Right.
while Thornhill predicted the first flash along with the second flash, he predicted both. He predicted that, and I'm like, well, damn.
And yet
This
somehow
doesn't work.
we don't detect an electric field. So here's the thing: that's the measurement. It's not there. So any other explanations
So
based
that's
on
going to be
electricity
something that
have
I'm
to be
going to have.
wrong.
That's going to be something I'm going to have to look into, because what I've always understood is we don't have anything that can measure a quote unquote electric field that way. Because I was always thought like, hey, when I get in my car, I start my car up. I have a Escalade. I can see the battery voltage. Okay, that some vehicles don't have that. Some vehicles, a light will just come on a dummy light whenever your battery is going bad or your alternator is on the fritz. So
Mhm.
I wasn't aware of any electrical devices in these space probes. I've never heard that before, to measure electrical fields. I've never heard that. I've heard the opposite, that they don't really have anything to measure the electric fields. That's why guys like Dr. Scott have to rely on the magnetic field strength to try to determine how much charge is necessary to produce a magnetic field using Maxwell equations and doing it that way. I've never heard of there being any electrical devices in these spacecrafts. This is the first time I'm ever hearing it in my entire life. So I have to look into something like that. So I'm open-minded enough to say,
Yeah.
okay, let me look
So
then to see what you're talking about, because I've never heard that before. All I know is fundamentally, just from a layman's perspective, again, magnetic field, moving charge. You're saying no charges can be detected from comets, maybe the sun, gas giants. Hell, I mean, I can, from my fundamental understanding, and it's just very basic from what I've read in these books, then I could say, okay, the Earth's magnetic field is stronger because the charge is stronger within the Earth, deep within the Earth. Mars has a weak electric field. Saturn has a pretty strong electric field, but not strong as Jupiter's. But Venus doesn't operate that way for some reason or another. It's just like a hot thing, I'm going to call it. Mercury has a weaker electric field, thus it has a weaker magnetic field. So I look at the two together. If you have a weak magnetic field, you have a weaker charge. If you have a stronger magnetic field, you have more charge. I mean, that's just the way I'm looking at it from these books. You know what I'm saying? I'm not saying that these guys are 100% totally right. You're 100% totally right. I'm like the guy that's like looking for answers, and I need the easiest path to problem solve. And to me, this is an easier path to problem solve, though it, like you said, may not be accepted by mainstream. Now the accusation is Sapphire doesn't have peer reviews, so that just disqualifies them. I don't say it disqualifies them because they're not peer reviewed yet. I'm not saying that, or nor am I saying, because Montgomery Childs would be better to talk to. He's not. He's really he's a design engineer. He's the guy that's saying, hey, if we don't understand this or why it does this or that does that, then that's what we're saying.
So there's actually a key thing that we might want to highlight here.
Mhm.
You mentioned like these various people, and they say we can't understand, but is it that we as the scientific community can't, or he can't? Because here's the thing: I talked to a physicist,
Mhm.
and they are not confused by comets. They are
Okay.
not confused by the sun in the same way. So when they're saying there is no such explanation, and you talk to the people who work in the fields, and they say, no, that's not true. We have lots of explanations and lots of evidence and
Mhm.
experiments and documentation for the reasons we say the things that we do. That should not be compared. And to find the one rogue person who says there is no explanation versus the thousands of people who work in the field say, no, we understand this pretty dang well.
Yeah, no, he admitted, because because Montgomery Childs is a design engineer, that maybe particle physicists and some other people could come together to explain why they're getting the results from the transmutation of elements that they're getting. It's predicted that it should do that. The sun should do that. And they're saying, okay, we've done it here. This is probably why they can't do it here with these big nuclear reactors and what they're trying to accomplish is with the nuclear fusion. Maybe they're doing it wrong. Maybe we're on the right path. Maybe it's a little, maybe there's a truth point in the middle, but then one side might have to admit that they're wrong or not all the way right. Then that becomes confusing. And I don't think that'll ever happen. I mean, me personally, I don't
Well,
think
here's the
that'll ever
thing.
happen.
If you want to meet in the middle, then you
Mhm.
actually have to put out your results for everyone else to examine. If you just say 100 excuses for why we're not showing you our results, and the people who are working at ITER, the people who are working at the fast fusion ignition system are publishing papers and their results all the time, they're completely open about the results and the
Right.
limitations on what they've had. Why is it that this group somehow thinks they have uncovered the entire secrets of the universe, but won't actually have it criticized by the people who would know better?
Well,
That is
I think
pretty darn suspicious.
I think right now what's happening is what little bit you've looked at, you're going to dismiss it. Is it just because it's not peer reviewed, or because it's outside of your discipline, and that
No, it's not actually because it's outside of my discipline.
okay,
I read stuff outside of my discipline all the time. I
yeah,
do biblical
that's what I'm
studies.
trying to say.
That's
Okay,
definitely outside of my
all right,
discipline. On the other hand, if they are not actually publishing for people to look at their results, and the result is initially extremely unlikely based on known theory,
hmm
then we should be skeptical. They might as well have said in their plasma system they had an elephant just pop out,
yeah, I
and they're
don't
saying,
think
"Well, we haven't published it yet, but we will at some point." It's like, no, we have lots of reason to suspect you did something wrong, and we are really worried about that elephant.
yeah, I mean, well, Laren's making comments that they are privately funded. They need to make money because they're not being paid. They're not being, the government isn't funding them. They're not getting grant money to do this stuff. I think they came up with several $1 million on their own and from private funding. I know that that's what Dr. Child said. He can't, they're not going to just push it to the public till they get their patents together. That's their, that's their baby. That's their baby. And I'm like really impressed at what they did. That's their baby though. They're the ones that came up with the baby. And it's like, well, let's make sure our baby is protected first before we just push it out there. Now, when they push it out there, it's just, I'm a DJ. So one turntable company existed, and there was one turntable, Technics SL 1200, since the 70s. You had to buy the Technics SL 1200. Well, once the patents ran out or whatever, what have you, now there's tons of turntables you can buy. Pioneer, you can buy
Mm-hmm.
different brands, but they're based on the same technology. And that's kind of the way I see it. That they're like, hey, we're going to do this first, and we have patents pending. And I looked at a chart of what they had patents pending on. If that's what they're saying, then I'll just go with that, because I'm not using the Sapphire project. I think
Here's the
what
thing, and why I know that actually that's not a good excuse, because there are
I'm not
tons of
making an
companies
excuse.
who have published materials that like have patented materials and push out papers all the time. For
Hmm.
example, NVIDIA is a really huge company that does a lot with computers and algorithms and that, and they publish papers all the time. They're a big private company. Uh, all of our major pharmaceutical companies, publish their results to actually show why we should be taking their medicines. If
Right.
if Pfizer came along and said, we have this new pill that will extend your life for 10 years, but we will not show you any of the results to back that up, why would the FDA ever approve that? And why should you ever take a pill like that?
Right. I'm not force feeding it to people. I'm not that guy that's like, hey man, look at this. People can look at it. My son looked at it,
Then
and he
why are you
goes,
claiming that they've actually
hold
done
on,
these
hold on.
amazing things if they
I would
can't demonstrate it?
say
It'd be the
I
same
would
thing as Pfizer saying,
hold on, hold on. So
no,
so
no, no.
what,
It's the
no, no,
exact
no.
same
I
thing
get, no,
as
I get where
Pfizer
you're
coming
coming from.
along and they have a brand new pill that will extend your life for 10 years. Sure, it goes against everything else we think in biology, but we're not going to publish it because of our patents. But you should believe us. No, we're not going
No,
to
I'm not
believe you
saying believe
until
it.
you
I
can
didn't say
actually
believe it.
demonstrate that.
I didn't say believe it. I'm saying they
You've been
demonstrated
telling
it.
me they've had these results. You've told
Okay.
me they transmuted elements.
Yes. Yes. Um,
So you claim that's true,
it's
or are
not
you
if
just
it's not a
claiming that's what they claim?
if it if it's not up to your standard. I respect that. I do respect that.
There is no standard in this
But I
case.
think,
There's no
okay,
evidence.
but I think, okay, again, but I think what happens is, again, you mentioned earlier when we had our pre-talk, we're talking about two different paradigms. You're saying, well, no, it
This
really
isn't
doesn't have anything
paradigm.
to do with
You got to
paradigm.
show me the
Sure, it does
results,
have a
or you got
paradigm.
nothing. This is not a matter of paradigm. If you have no evidence, you have no paradigm.
Okay, that's what I'm saying though. Your paradigm is different than
Is
my paradigm.
show me the evidence. That's my paradigm.
Well,
you got no evidence?
I think we're evidence based too, and I think you're
Where is it?
Not as much evidence based. Again, I'm going to say it one more time.
Where is the evidence published?
If the sun is a nuclear fusion furnace, okay, and I'm using that terminology, okay, can we duplicate that on the Earth? Yes or no?
We don't need to. We have other ways of determining if that hypothesis is true or not.
Nope.
Stop.
You moved the goalpost.
I didn't.
Is there experimental evidence to sustain a nuclear fusion reaction to prove that the sun is what you claim it is? Yes or no?
Are there experiments we can do that conform to the hypothesis that the sun is a nuclear fusion reactor?
So we have direct evidence from experimentation that it is a nuclear fusion reactor sitting up in the sky.
That is correct. That is actually the evidence we have, in particular from neutrinos.
And not okay, because that's another. You're saying because of neutrinos, that's how we know it's the truth. I'm saying, can you do it? Can you take atomic hydrogen and duplicate the sun in a laboratory, no matter what the scale is, and make a sun in a jar and make it work the way the sun is working? We should be able to do that. We wouldn't even have an argument right now. I'd be like, hey man, the sun's a nuclear.
Ask yourself the question: why haven't we been able to do it so far in a physics domain? Why is it that it's been so difficult?
Because the sun probably isn't a nuclear fusion furnace.
Maybe because the sun is gigantic, and the reason it can sustain fusion is because it's about a million times bigger than the Earth, with extremely high densities at its core, something we cannot possibly manipulate and have in the lab, where anything we'd have there would just completely evaporate on us. We can't produce the sun here on Earth, because if we did, it would not actually function for any period of time. So instead of that, what other ways, what other measurements can we do that would actually either confirm or refute our hypothesis? That's how we can do so much of science. We can't go back in time and see what the Romans did, but we can see what was left behind. That's the sort of thing. What sorts of evidence would we expect on our hypothesis? That is science. What do we expect? Can we go out and meet that expectation? Does it pass the crucible of experimentation? When it comes to the sun, it makes predictions of having been a nuclear process. It should give off neutrinos. It should give off neutrinos of a particular energy regime. It should give off neutrinos at a particular number. And we've done those experiments, and we have found that actually it conforms to what we expect.
Okay.
And there's nothing else. There's no other competing hypothesis that predicts neutrinos of the same number and the same energy regime.
I was going to say that they're going to disagree with you, not me. I'm not saying I disagree with you.
They can disagree, but they got no evidence to back it up.
Okay, listen, I'm going to say again. So then the neutrinos is how we prove the sun is what it is, but it doesn't account for the charged particles. How do you?
What charged particles?
When there's a CME, are those charged particles charged or not?
They're charged. I don't see there's.
How does that work? Then how do you get?
Because when you get something super hot, you turn into a plasma. That's basic physics for that.
Okay, so then so what you're saying then, and help me out here because that's more chemistry. So then we go from hydrogen to helium. The hydrogen becomes super hot to produce the helium, which is conductive, and we know helium's conductive. We know neon argon.
It's not a matter of conductivity. Here's the key thing about what a plasma is. Plasma is another state of matter. It's like how we have solid, liquid, gas. Mm-hmm. Plasma is another state of matter. Its key feature is that it is not atomically neutral anymore. Its electrons have been stripped away, so we only have the nucleus of those atoms. That's what makes a plasma.
Okay, so we can make plasma from hydrogen then. Hydrogen.
Anything that gets hot enough will become a plasma.
Hot enough. They're not going to say that's a plasma physicist isn't going to say that. They're going
to no. That's straight up physics.
But they're going to
like I say, it's another state of matter.
When they go into the lab, they're going to say no, it has nothing to do with heat.
Then they're wrong. They're fundamentally wrong.
They're fundamentally wrong. Okay, and you're laughing, but these guys that are
don't know what they're talking about.
So
yeah, exactly.
Pratt doesn't know what he's talking about.
Exactly.
He wrote.
If they claim heating up a gas to a super high temperature doesn't turn it into a plasma, they don't know what they're talking about.
I don't. Yeah, because I don't think I've never heard that. I've never heard the explanation you just gave about plasmas ever from an electrical engineer ever. If you heat it up.
Well, then don't talk to electrical engineers about states of matter. Simple.
Yeah, well, electrical engineers they work with their electrical engineers first to be able to work with plasmas at that scale in the labs, and then it's scalable. So they're gonna talk about the electricity being scalable. you're saying no, we can't do those type of experiments because it's too much scale and it may not work. So we're going to do it this way.
I haven't said anything about scaling.
Well, you talked about fusion models and heat and reproducing.
I was saying we can't generate the core of the sun on Earth because it requires basically the entire mass of the sun to crush things down.
Why? Why can't you do it at a different scale then? Why?
Because the energy is required to actually get two protons close enough together to actually undergo fusion is gargantuan, and we know this from basic fundamental.
You're going to dismiss it, but they got that plasma chamber in the Sapphire lab.
That's a claim again without any evidence.
6,000 degrees.
You can't tell me
that chamber was a couple million degrees, and they did it over and over and over and over again, and it wasn't.
How do you know they did what they claimed they did?
Okay, so now again, this is where it gets sticky because I watched.
They haven't shown it.
You're saying it's a fake video.
They haven't shown it. They can't say they know it.
They have a fake video. You're claiming they have a fake video.
How do you know in that video they have the temperature measurements they claim to have?
So now Montgomery Childs.
You've already said. You've already told me in those videos. You've told me about the videos, yes, but you've told me that people who actually verified that there was a transmutation of materials was at another lab. So those videos showed zero evidence of transmutation of metal.
Okay, so if it were true, let's just say if it were true, let's say it's a bunch of malarkey. If it was true, then some of what you're saying to me right now is not true. If what they're saying is true, that's not published, so there's no way of you knowing it. I understand what you're doing here, but at the same time, you can dismiss it and say, well, it's not published the right way, so I don't know. They can't do that because of the example you gave, which is fine. I'm saying I watched it, I followed it, and if they're saying that they did it, I don't think Monty Childs and Dr. Michael Clares are just some run-of-the-mill fringe guys that have this weird idea and they're just making the whole thing up.
You say run-of-the-mill fringe. They literally are running a fringe theory about the universe and mythology. It is fringe. It is not mainstream.
All science comes from being fringe at some point. That's why we have electricity right now. Damn, if I saw the spark gap experiment back in the day, I would go, whoa, no more candles. Now the candle maker is going to go out of business in several years because we have gas lamps. Now we have electricity. We have hydroelectric plants. It was on the fringe at one point in time.
Electricity was never a fringe theory.
Why wasn't it? It started on the fringe. Everything starts on the fringe, I would say.
That is not true.
Damn.
And unfortunately, now that means your history of science is wrong too. Again, if you keep listening to people who are on the fringe, you will only get more and more fringe thoughts to back up the fringe things.
So
you are now being told about things about plasma that are wrong. You're being told about comets, things that are wrong. You're being told things about dark matter that are wrong.
Okay, according to you, and I'm saying as an independent researcher.
And everything I've said, you can go and actually verify.
And an independent researcher.
Published material. I don't have to claim there are patents that are hiding my answers.
Because it's published doesn't make it true. Because it's peer reviewed.
Because it's published, you can actually check. If it's published, you can check.
Okay, you can check. So besides the Sapphire Project, you can go through the IEEE and check Dr. Scott's papers and Wall Thornhill's peer-reviewed publications. You can check on Dr. Peratt's work. You can look that up yourself. I mean, damn, though it's outside of mainstream cosmology doesn't mean that what they published is incorrect. It doesn't mean that what you
let's
have
actually stop for a moment here, because here's the thing. You've made many, many claims about what the Sapphire Project has done, and yet you've also told me they haven't published the truth of those results. They haven't actually shown they've transmuted metals in any published environment.
I don't think
and I've looked, it's not there. So why would I ever believe it?
Okay, that's fine. You don't have to. You don't have to. And I'm not saying you do. I'm not saying you
have to. And the thing is this, that we don't have good reason to believe their outlandish claims. And if really we have to throw out the sun based on claims that cannot be verified, we have every reason to dismiss it until they can actually provide the evidence.
Again, because I asked the question and it was never answered. The temperature of the sun's inverted. You have 6,000 degrees on the surface. Sunspot's about 3,500. Then it rises to about 2 million. Where's the 10 million? Deep inside the core. How do you measure that? How do you know the inside of the sun is that? From the neutrino experiments? Well, okay, if you say so. I don't know. And I'm being honest.
Well, what do you mean? Well, here's the thing. The reason I say this about the neutrino experiments is they have been measured by multiple labs from around the world over decades, and have shown their results and show that they are at the expected level of fusion processes going on in the ways that we expect.
Okay.
So you may not have checked the papers. That's fine. It's not like they're easy reading. They're not beach reads. I totally admit. But that evidence is published. It's verified. It's been repeated by labs all around the world. We've had neutrino experiments that have been running across the world for decades.
Okay, without again moving the goalpost with different flavors and switching. I call it moving the goalpost. Like we move the goalpost.
The thing
over.
is, it's not moving the goalpost. It's now we understand neutrinos better.
Move the goalpost over here, and then now
here's the thing, though.
Yay.
You keep saying move the goalpost,
Yeah.
but here's the thing: do we actually have evidence that neutrinos change their flavors? We actually do. One of the ways we did that is we created a beam of neutrinos, fired it through the Earth, and then put a detector on the other side to see if the results were actually giving the expected result. Was it the case that we could actually detect neutrino oscillations? Yes, we could. It was not an arbitrary thing. It was something we went and actually did experiments to see if it was the case. That's not moving the goalpost. Okay. That's doing more science.
Okay, then we measure the neutrino. The rate of neutrinos expected is what it has always been from the very beginning, right?
What do you mean from the earlier
ratio? The ratio of neutrinos. Okay, it's always been the same. I'm not a scientist, but they're going to disagree with you. You guys would have to come together and bang heads on that one. You know, honestly.
Well, here's the thing. I actually looked in some of the videos on the Thunderbolt project, and what they claim about neutrinos are actually contradictory.
The books would be more impactful, but again, I don't have my glasses, and I have to look it up.
Yeah, well, like I said, from the video material I saw there, that they both claimed that there was a dearth of neutrinos and the ratio was wrong. That can't both be true. The ratio is to explain why we only saw 1/3 the expected number of neutrinos in the first place. Okay. So they don't seem to fundamentally understand the neutrinos.
So then the first time when a third less was expected, that was right or wrong then? Wrong, correct?
It was because we expected...
Because, see, that's where they're going to say, no, there is no just because. Now you're going to readjust everything to fit
because
evidence.
We learned more. We learned more.
But you're fitting evidence into the conclusion you already drew. Instead of
we actually discovered more.
That's what I'm saying.
What would happen if we discovered more and we didn't include it in our theories?
That's the thing, though.
And how many neutrinos, again, are expected from the electric theory? 0, nada, not a 1.
I think that's true. And again,
that is true. If that is not right, then we have to be wrong about electricity, magnetism, gravity, nuclear physics. Everything has to be wrong.
I want to say,
it is the wrongest wrong you could wrong.
And again,
they can claim all they want, but they're wrong, and that's why they're on the fringe rather than the mainstream. It's why they can't publish anything in a physics journal, because they're saying wrong physics things. They might as well say 2 + 2 = 5 in the right context. No, it's always wrong.
And then again, and it goes back to the original conversation. So your science can adequately give explanation for then, because that's what they're saying, that their science gives a better explanation for the past. So then mainstream science gives us a better explanation of what happened on Earth in the past, whether it be the geological features. Hold on a second. That's allowed.
Well, you mentioned going about the past, so let's actually talk about the past very quickly. We don't have too much time left, so I'll try to be somewhat
geological features, the archaeological layers having destructive layers, uniformitarianism, explaining the Grand Canyon, Monument Valley, some of the anomalies that we see on the Earth. I think their explanation to it is better than a uniformitarian explanation. That's just my opinion.
Here's the thing. Now, if we're going to say that actually also the geologists are wrong and they're not publishing anything in geology journals to see what a geologist has to say, again, that's mighty sus.
And I think I think that mainstream cosmology, like the Saganites.
Well, now we're not talking mainstream cosmology. You're talking about geology.
Because they're saying that those two are flipped. They're out of place. They're saying that
now it's a worldwide conspiracy across all the sciences.
It's not a conspiracy. It's saying that those two should mesh and meld together the right way, and they don't, because then now you're not going to be able to explain upheaval domes. You're not going to be able to explain the reshot crater and that chain of craters that goes up toward the Mediterranean.
Why is it then that the geologists don't say that?
Don't say what?
They don't say these things are impossible on their uniformitarian or geological models.
Yeah, because they're going to say something impacted it. Boom. But then it's, for instance, when I look at the reshot crater, and then I look at electric discharge machining in the laboratory, and we put them both.
Why don't geologists believe that?
Because they're maybe not looking at it that way.
Why haven't they published? Why haven't the Electric Universe people published in a geology journal about their geological findings?
And I think some have, but don't quote me on that. I think
it ain't there.
Okay. Anyway, what I'm going to say is they look for patterns. You're shaking your head. Wait, slow down. I know you breathed. I know. So the reshot crater, you've seen the reshot crater before in Morocco?
Yeah.
Okay.
And here's the thing. That is a feature that geologists have an explanation for that doesn't require giant amounts of lightning?
Then can you reproduce it in a laboratory to show it?
Can someone produce a giant electrically charged Venus and shock the Earth? No.
I don't think they said
So
that.
I guess we should
Okay,
dismiss
wait a
it.
minute, but you can do it in a laboratory and show it, and it looks
Can
exactly the
you
same.
charge Venus so much
You
that it shoots
can
a lightning
look.
bolt to the Earth?
I don't think that that's what they're saying. That they're not saying.
No, that's
that.
what you're telling me, that we
I
need to
wouldn't. I
reproduce
don't
the
believe
sun
that.
on Earth.
No. Hold on a second. Back up. What I'm saying is, if I look at the Reshot crater and I look at the chain of craters that goes up towards the Mediterranean, and I look at electric discharge machining at a different scale in the laboratory, they look exactly the same. Both of them.
I'm asking you though, what do the geologists say about it?
They probably would say it's an impact.
How have you actually checked what the geologists say about it?
I think just from my general research, and I'm going back to my school days, that's what the explanation was. There's have to be an impact.
So your vague memories from the 7th grade. In other words, you haven't checked.
Well, so what's the explanation then? What's the geologist?
How about we actually look instead of just speculate about what geologists say?
I don't think the geologists are saying. I think they're saying impact. I know the upheaval domes has to do with salt.
You haven't checked. Do not tell me what the geologists say. You have not checked.
So okay. Well, I'm going to make the claim again. What they are going to say is, I can duplicate the Reshot crater in a laboratory and make it's exactly the same, one from the other. You can't differentiate one from the other from an electric discharge in a laboratory. Boom, boom. There it is. They look the same. It looks like a duck. It walks like a duck. It's a duck.
Here's the thing. Then why is it that people who look at ducks aren't saying that?
Because of paradigm, and I said that before.
But you don't even know what they claim. You do not know what geologists say about this feature.
I've always remembered, again, and now you're trying to nitpick. I've always remembered the geologists talking about impacts for those structures, not the upheaval domes necessarily, but for craters on the moon, like craters we have on the planet. They're impacts. So that means every impact would have to be at 90 degrees, whether it's the bottom of the moon, whether it's the sides, whether it's the top. Everything's coming at 90 degrees.
That's actually false.
Okay, well, that's the way it looks. It looks like if there's a crater underneath the moon, that it would have to come at a 45 degree or 90 degree angle. I'm sorry, 90 degree angle. I always see things coming into our solar system at more of a 45 to a 30 degree angle this way, not that straight down. I've never seen that before. I've never seen an
We've
impact.
actually done experiments in labs to show if you shoot something not at 90 degrees but at 45 degrees, it'll still produce a circular crater.
With the same exact features?
I'm not going to tell you about the exact features because I haven't looked at those.
That's all I'm saying, is there's a lot of levels to
but
this.
But you have not checked, so do not tell me what they cannot explain.
So again, and I'm not here like.
But no, here's the thing: you were telling me that the only way a crater can be formed is something coming at 90 degrees, and I'm telling you, actually, no. You talk to the people about impact craters, and the comets or the meteors can come in whole variety of angles to produce the same shape.
And drill straight down into the planet, and drill straight down with that way. Spiraling that way? I mean, I don't know how that works. I would think.
I don't know about the spiral features you're speaking of, but again, here's the key thing. Here's the key thing. You made a claim about what geologists say, and you have not checked that claim to be true.
Impacts. Am I lying to say that they're impacts? No.
Is it the case that that feature in the Sahara was caused by an impact? Is that what geologists claim? You have not checked.
I would say yes. And that's something.
Have you checked? Have you checked?
I checked many years ago, and I would say yes, they're impacts.
When you were in grade school, when you can barely remember, that's not checking.
I would say within the last 10 years, I checked. So is it an impact?
No, that is not what you said. You said earlier you remember back from being in school.
Okay, we've been taught that fundamentally in geology class for a long time. They're impact craters on the Earth. So
that is not the same thing as saying, what about this particular feature? Are geologists saying it's an impact crater? Is that what they are claiming? Have you checked?
I said, yes, it's an impact crater. You're saying I'm wrong?
Have you checked? Have you checked? That's what geologists say.
I said I checked. I said I've looked at this stuff. So when I'm reading these books, I don't ever look at electric universe stuff and not do outside research to see, okay, what do these people say? Well, what do these people say? As far as I know, that they're impact craters. But then I'll be looking for the debris and why they're rimmed and they're circular and why it looks the way it looks with electric discharge machining in the laboratory or in industry today. It looks the same to me, like it's exactly the same. But I'm not the one that's saying that Venus caused these huge lightning bolts. I'm saying that if you have an electrically charged solar system with charged particles, then if the sun is producing more charge, our weather would be ridiculous, I think, on this planet. It would cause chaos. We see the fossils embedded in sandstone. Like, that's kind of bizarre. It really is. You have large fauna infused in the Dakotas in sandstone. You have fish swimming in sandstone. The bones aren't crushed. I mean, damn. I'm just looking at it from a different point of view. That, hey, if
Well, you
ancient
mentioned a point of view, but again, stop and ask, how do the paleontologists explain that?
again, do all the disciplines an agreement this way? I don't know if a paleontologist give me the correct explanation of why.
Have you checked?
Sure, but listen, I don't.
But you said you don't know what they claim.
But they also say that woolly mammoths, that this extinction event happened way long time ago, before there were human beings. Damn, you have some of these mammoths that are partially, which we call petrified, I guess, and partially not. Like, damn, how does that work? I'm just bringing it up. So I'm not trying to incite your emotion. You seem like you're getting a little upset at what I'm saying or something.
The thing is, you're making claims with no backing up.
I'm saying there's.
And I have gone and made sure
if it's not up to your standard, if it's not up to your standard,
no, you have no evidence. That's not a matter of standard. That is
evidence.
You haven't shown one bit.
I'm not showing anything.
Not one.
I'm not showing anything. We're talking.
You've made claims, exactly. You only have claims.
So we're talking right now. We're just having a conversation. We're having a simple.
But you've made claims. You've said people have done this, that, and the other thing.
I've seen experimentation that's blown my mind, and I'm like, well, damn. Why isn't the world going? Holy crap. I mean, you have this.
Yeah, why aren't they? It's almost like they're wrong.
It's paradigm. You're a uniformitarianist. I'm a catastrophist.
I'm saying show me the evidence.
You're coming from two different worldviews. Your worldview is different than mine.
My worldview is show me the evidence.
Okay, and I'm saying you show me the evidence. You're saying we have the evidence, and I'm like, well, how? How do you?
I already
have
explained several ways.
You don't. Several ways isn't up to my standard as an intelligent person. It's not up to my standard to say.
Have you looked at the papers on neutrinos?
The sun and the neutrinos is because we know these neutrinos work this way. Boom. And that's what the sun is. Because Eddington looked up in the sky one day and saw an eclipse and said, "Yep, there's an oven in the middle of that sun and it's burning really, really hot. Yep, it works that way." I'm not sold on that. I'm not so, because we can't sustain.
Well, first off, actually, Eddington didn't have that sort of solar theory. And secondly, he wasn't just looking at the sun like that. What Eddington did was he was actually measuring the effects of the gravity from the sun on starlight. That was the experiment that he did back in 1919 to try to help justify Einstein's general theory of relativity. And it was one of the groundbreaking experiments that made Einstein a household name. It was later physicists who then were coming up with the nuclear theory of the sun. Back in 1919, the idea of atomic fusion didn't even exist yet.
No, I get that.
And the ideas in particular about the chain reaction going on the sun is much later. And it comes from people like Fred Hoyle, for example. He came up with the CNO cycle for explaining a lot of features about nuclear fusion in the sun. It wasn't Eddington just looking at the sky and just coming up with ideas.
I'm being a little sarcastic about it, but nonetheless, I knew.
But here's the thing. I'm not having to be sarcastic. I'm saying here are the dozens of experiments done around the world to detect the things expected by the theories and have gone and been verified and been cross-checked about multiple ways of doing that. And you can go and you can look up all that evidence that is published around the world. In fact, in free journals, you don't even have to pay necessarily.
Right.
For example,
the consensus got it right. We're good. We got it right.
I'm saying the consensus has the evidence.
Okay, because you're saying they do. These guys are saying they don't. It's still another argument for another day.
An argument with no evidence.
Okay, not so much with me, because they're going to look at you. I'm not going to do that to you, but they're going to look at you and say, hey, you know what? This guy is saying that we have the evidence, but that evidence was fitted into the prediction after the prediction was wrong. That's what they're going to say.
Can you show me the paper where they predict the number of neutrinos from the sun? Because you can't.
Well, you said it was.
That's what I would call fitting. Because
you said it was a third short.
The number.
Here's
the thing. Here's the thing, though. The number of neutrinos expected from an electrical model is exactly 0. Anything you do to make it not 0 is literally fitting to the evidence.
I don't. And again, since I have my pages bookmarked for other reasons, and man, we could really again do another call, because I know Dr. Scott at least said that they do predict neutrinos, but not the amount that and the ratio that you guys predicted. Now, I don't know
You
how
mean the
that
amount
works.
that we've actually gone and verified? So in other words, they came
Yeah,
up with
I
another
don't think you
hypothesis that's
verified it. I
wrong.
don't think you verified it. What they're saying is you came up with the flavors after the fact, which makes your prediction right,
Again,
which
that is
was
actually fundamentally false. The idea that there are different neutrinos, the flavors of neutrinos, was already something that had existed in particle physics, and that neutrinos can oscillate was something that was allowed in the standard model of particle physics. They thought that that was not the case because we thought neutrinos had no mass. We then actually did the experiments and did discover that indeed neutrinos do have mass, they do oscillate.
okay.
So in other words, we actually went and we learned more and more about neutrinos and built even better and better experiments to go and verify what we had been thinking. In
Okay,
other
so
words, we did cross-checking. We went with multiple methods to try to converge on a solution and had it verified by being repeated by experimental labs around the world.
so based on that, the sun is 10 million degrees inside, about 3,000 at a sunspot, 6,000 on the surface, and in the heliosphere is about 2 million degrees based on neutrino evidence, correct?
The neutrinos is one of the major lines of evidence showing that there's a nuclear process.
Okay, so again, will that adequately explain the inversion of the temperature and then prove that the inside of the sun is 10 million degrees? Does it do that? Does that experimentation without any doubt show that's why the sun is operating that way?
I will never
I
say
guess my
without
question.
any doubt. Because
Yeah.
I'm a scientist, I always know
Okay.
there is the possibility that future evidence can come along and change our minds, our conclusions. We find flaws in the experiments. So I will never claim absolute 100% confidence. What I will claim is that the neutrinos we are detecting is exactly what we would be now expecting based on a nuclear reaction going on in the sun. In fact, the most recent experiments on nuclear solar neutrinos is now become so sophisticated they can now tell the difference between neutrinos that come from a proton-proton collision and the CNO cycle, which we think is also a major component of fusion within the sun to explain not only the sun's current system, but also in the past. One of the things we also know from geological evidence is that in the past, the sun was cooler. And we can explain that because of how the sun has evolved over the last 4.5 billion years.
Oh, wow,
so that's actually another thing that the fusion model can explain. Yeah.
I mean, so then what I was told in school, and I'm talking high school, I was in high school in the 80s, came out in 87 and came out of college in 93. So I'm not, is my body being bombarded with millions of neutrinos when I walk outside my door? That's what I was told.
Even more.
At that point.
Actually, it's even more than billions. It's a gargantuan number of neutrinos. Yes.
Hold on, I'm gonna have to put you on mute. This is something about me broadcasting. No. Can you hear that? Can you hear that?
I do hear something. Yeah.
There's a train. I live. There's a train station. This room that I'm in used to be a flower store. Okay, and there's a train that comes through here and everything. So, yeah, the train came. Was it that bad? Because I need to know. This is the first time I broadcast from this room.
Very weak. I was kind of hoping, though, you would at least do this.
I hate when they do it, though, but they have to. Somebody got killed years ago. That's another story. So
right.
We can detect millions of neutrinos. Okay. You're saying that's a true claim. So then I can now, since you've made that claim, then I can go back when we're done. I can open up Dr. Scott's book and I can then do research. That's the type of person I am. I can do research and I can corroborate it.
Why would you corroborate with Dr. Scott's book? Why wouldn't you go to the actual physics?
No. Hold on a second. Because I'm a comparative guy. I don't care. Again, if something is accepted, and this is I call that appeal to authority. You know, that's a logical fallacy.
You're appealing to that guy's authority right now.
I'm not appealing to it. I'm saying through
my
research.
You just did.
Through my research, I'm going to look at two sides of it. I'm going to look at both sides. You are looking
at the second side by looking at the same source to talk about both sides.
I'm going to look at both sides. So in my journey this way.
Why are you looking at Scott's book and not what the actual physicists are publishing?
Hold on a second. So during my journey, I
don't care about your journey. Why are you not looking at the actual physics papers?
I'm going to mention it. I'm going to say it again.
Don't mention it. Get to it.
That's
what actually matters.
I'm in 5 lanes. I'm in like 5 different lanes here. So one is cosmology and geology. I'll call that one lane. So yes, I'm going to look at what the mainstream science papers have said for years. Hell, I've even heard about wormholes and stuff. Like, damn, black holes. Okay, I get that. What does anybody else say that may not agree with that? You close your eyes, but hey, do I have to agree that a black hole is going to suck me in? Ooh, we're going to get sucked into the black hole. No, I don't have to. But you're saying that by me looking at this right here, that this is a problem with you. It may be a problem with you. It could
I'm
be.
saying if that's how you're going to look up the issue with neutrinos, it means you're not doing real
Since
research.
they're the ones that are saying it, okay, since they're making the accusation, let's look at them. Let's look at these guys that way. They're making the accusation that something is wrong with the standard model. So I'll look at what they say, then I'll just go back to the standard model. It's pretty easy. Instead of you saying, well, let's look at the standard model, because that standard model that you are degreed in did nothing for me to explain the past at all, especially the last several hundred years. You're not going to convince me that science, because cosmology and geologists got this story that goes back billions of years. It explains.
This is
It
actually a
explains like
methodological issue here.
explains like the last several hundred years of very destructive.
I'm sorry, I
human
need to interrupt for
ahead.
two major reasons. One, I literally have to go in 5 minutes.
That's cool.
Because we've been at this for 2 hours. Thank you, Jacob, for tolerating me.
No.
But secondly, there are two methodological issues that you're hitting on right now. And I want to hit both of those before I have to run away. The first methodological issue is, if you want to know what the mainstream view is, you need to actually read and find out what they say, not what other people claim they say. Go to the actual original sources. It'd basically be just like if you were still a young Earth creationist and you want to know how people explain fossils, you read from Ken Ham rather than from the actual science journals. If you want to know what the scientists are actually saying, how they explain things, and what evidence they use for it, and on all the various papers they've published on it to show the evidence that they've gathered, the other groups that have gone and done the same sorts of experiments, et cetera, you need to go to them and actually see how they argue it, what evidence they have. If you only go to that particular book, you are basically staying in a partisan bubble. It would be just like Republicans only watching Fox News. That is isolation. If you want to know what the other side says, listen to what the other side actually says, not what other people say they say.
Okay, that's fair.
That's a methodological point.
If you're going to make that point, I mean, you're entitled to make the point that way. I'm still going to do it the way I see fit, to me as an independent researcher or a journalist, to say, okay, I've considered what you're saying. I'm listening and considering what they're saying. Where's the truth? I need the truth. I don't need. Well, we did it this way and we figured out that I need the bottom line. I need the bottom line, because I think as human beings, we deserve it. We deserve the bottom line. And I don't see, personally, again, it's not a personal attack on you because I've enjoyed this conversation. I need answers as to the past and why people behave certain ways and are still behaving that way today, even recently.
Yeah, on that point about trying to explain the past, the way I try to explain the past is, first off, what do we actually know that we can confirm, rather than we read the past and then we try to force an interpretation on that to the rest of the physics that we can actually verify. If the electric universe stuff is false because of the experiments we do, we shouldn't be then trying to use it to explain the past. Instead, we should go back and say, okay, since that physical theory can't possibly work, maybe there's some other interpretation. Maybe there's an entire flaw in the way we approach it. In the exact same way, if we go back about 200 years in biblical studies, they were trying to explain every single miracle story of the Bible completely in terms of physical law, that people were just confused about what they saw. Jesus walked on water. Oh, no, it was just a dark and stormy night, and he was walking on the beach, and they got confused. Jesus rose from the dead. Oh, he actually just fell asleep on the cross, and when he got back up, everyone was confused about it. Obviously, that might strike us as silly nowadays, but that was literally the paradigm in biblical studies then, because they were forcing what they believed onto the text rather than letting the text speak for themselves. So my approach would be, first off, what can we, verify now? And if something doesn't work now, I shouldn't be trying to use it to explain something in antiquity. And secondly, also, I will note that when I have tried looking at the evidences that are brought for the various things in those ancient texts, they actually say quite different or even the opposite. So, for example, most cultures have a flood myth. Does that justify that there was a worldwide flood? Actually, no, because one, we have checked that there isn't some giant flood layer across all the world in historical time. And two, the flood myths are extremely different. Like, you go to China, what's the flood myth there? Was it that the whole world was destroyed? No, an engineer got his work together and actually stopped the flood. That's completely inconsistent with the biblical version.
Right.
So that's my thought. It's like, hey, are we forcing our interpretation onto these stories rather than letting these ancient people speak for themselves? And sometimes, unfortunately, we've lost those voices. Like you mentioned, petroglyphs. Yeah. I really wish we knew a better way to interpret them because we don't have the words. I want to make sure that we do not impose our modern sensibilities, our modern hopes onto people who can't speak for themselves anymore.
Right. No, I'm in agreement there. Because there's more layers to this. Because I don't need Electric Universe necessarily to talk about geological features of there being destructive layers, not a flood, and there being destructive layers in urban areas. I don't think we have to do that. I don't need Electric Universe for that because Dr. Gunnar Heinzholm, Professor Heinzholm, doesn't have to do that. He's just like, let's look at the archaeological layers when everything was excavated recently and let our eyes determine whether or not there was some sort of catastrophe, maybe some ideas on that, and that the chronology of our history is probably way off kilter based on direct evidence. So there's other lanes to it and layers to it that I don't necessarily need Electric Universe to talk about. We can just talk about the information itself and kind of try to gauge what's going on a different way. Because there's some things that, you know.
One quick thing when it comes to the layers, I definitely see that. Yeah, when it comes to Electric Universe, there's layers. But two other things that also have layers are onions and ogres.
Yeah,
getting down to the layers of onions is great. Getting down to the layers of ogres isn't worthwhile, and it makes the ogre very angry.
I mean, I get that. But
so there can be lots of layers, but it doesn't mean it's worth digging. And so my big problem is the physics doesn't work, and we don't need to then use faulty physics to explain the past.
What I like to do eventually, Dr. Adair, is to bring, if you don't mind me calling you Dr. Adair, is to bring on somebody who's more well-versed with the science. That's a scientist. I'm not a scientist, man, at all. You know what I'm saying? That's really, I don't have any skin in the game that way.
I will say, though, that from our conversation, you are definitely, I think, well-versed in what Electric Universe components say.
What they would say, yeah. That's why I'm prepared to say it that way.
So I don't think in any way that you're misrepresenting anything they've said. So that's why I can take the claims that you're making and not say, I need a scientist to say that. I'm just saying the claims, I've heard Electric Universe proponents say it, and I know it's wrong for X, Y, and Z. It doesn't matter if the person who says it is an electrical engineer or not.
Yeah, I just think that it's a better conversation to kind of take me out the middle of it, and then to have it would be a better conversation. My goodness, I know electrical engineers again and people in the group. I would like for that to happen. That would be something that would, you know, they should have been doing this stuff for years anyway. They have a private group, they have conferences, but to invite people to say, hey, you know, you don't have to agree, but let's talk at least, because there's other things to talk about except what we just talked about, which is fine. There's a lot more to this. When I say layers, I'm talking about still us as human beings. We're in this thing called the human condition. We're screwed up. We might not admit it, say we're screwed up, but we are screwed up. We're trying to figure things out. But then we see how our past is, and it's jacked up, especially in the African-American community. I'm sure it's the same way in the white community, where people are looking for answers to certain things, but then it can bend into pseudoville, and you're like, whoa.
Oh yeah,
I don't really want to talk about that right there. And you're
I'm pretty glad we didn't try to get into like aliens built the pyramids or Atlantis built the pyramids, because that's straight up Victorian level racism.
I mean, seriously, I would even admit then from these guys' group, Cuvier was like one of the first catastrophists. He's a fundamentalist, but he also came up with the scientific racism theory, man. Like him and some of his buddies, man. Like, hey, I'm not really, man,
the past came up with some pretty bad theories too. Now, unfortunately, my present theory is I have to run away, but I'm glad that we could have the conversation, and I'm hopefully the audience is still awake.
I know.
Well, I thank you both for joining me. I'm gonna play the outro now, and yeah, Sean, if you successfully are able to get one of those guys on, that'd be cool.
I'll work on it.
Have to see what happens down the line.
I think Dr. Adair was a great conversation, and you know, again, I like to get other people involved because they call me the historian of the group. I'm not a scientist, man. I'm not an electrical engineer. I'm a historian. I've wrapped my head around other aspects of human history, you know, than just the scientific part of it. So it's always a cool thing when people can talk and not argue and, you know, oh man, you're wrong, man, you're crazy, you know, that type of thing. So I enjoyed myself. Thank you again, Dr. Adair. Appreciate it.
All right.
Well, I thank you both again. I'm going to play the outro now.
Hello viewers, thanks for watching this video from the History Valley YouTube channel. Please don't forget to subscribe
and hit the notification bell. And if any of you wish to further support this channel, please consider checking out this channel's Patreon page and becoming a patron, and or donate through PayPal or through Super Chat during a live stream. Thank you.